Welcome, fellow seeker of ancient truths, to the shadowed archives where genetic memory preserves the saga of one of prehistory's most misunderstood predators. Tonight, we shall trace the long journey of the Dilophosaurus through epochs of time and corporate manipulation, from its reign in genuine Jurassic forests to its transformation into humanity's carefully controlled creation. Let the gentle rhythm of deep time carry you toward peaceful rest as we explore how this distinctive hunter became both icon and enigma, forever caught between its authentic ancient majesty and the diminished form that human ambition chose to resurrect. Close your eyes now and let the chronicle unfold like whispers from stone. In the morning twilight of the great age of dinosaurs, when the Jurassic period had settled into its rhythm of abundance, and the Earth wore continents, arranged in patterns that modern geography would never recognize, there lived a predator whose distinctive silhouette would one day become legend, though the legends would prove far removed from the magnificent reality that stalked through ancient forests with intelligence and purpose that exceeded anything the future would remember or acknowledge. The true Dilophosaurus weatherilli inhabited a world that existed between 201 million years ago and 174 million years in the past, during the early Jurassic epoch, when the great extinction event that had ended the Triassic was already a memory buried in stone, and life was experimenting with new forms and strategies that would define the character of the Mesozoic era. This was a time when the supercontinent Pangaea was beginning its slow dance of separation, creating rift valleys and inland seas that provided the diverse habitats necessary for evolutionary innovation on a scale that would never be repeated. In the region that would one day be called the American Southwest, where red sandstone cliffs would preserve their bones for human paleontologists to discover millions of years hence, the Dilophosaurus had established itself as one of the most successful predators of its age. Unlike the massive tyrannosaurs that would dominate the end of the dinosaur era, these creatures represented a more elegant approach to the challenge of killing, combining size sufficient to overwhelm most prey with agility that allowed them to hunt in coordinated groups through terrain that would challenge any solitary predator. The adult Dilophosaurus stretched approximately 23 feet from the tip of its narrow skull to the end of its long tail, with powerful legs that could carry its 900-pound frame at speeds approaching 25 miles per hour when the situation demanded such velocity. Yet these measurements, impressive though they were, failed to capture the true essence of what made this creature so formidable, for its success as a predator was built not upon brute strength alone, but upon the sophisticated integration of physical capabilities with social intelligence that rivaled anything that had yet appeared in the evolutionary history of carnivorous dinosaurs. The twin crests that crown the Dilophosaurus skull have become perhaps its most recognizable feature. Yet their true purpose remained mysterious, even to the paleontologists who would one day study their fossilized remains. These thin, semicircular ridges of bone extended from just behind the nostrils toward the back of the skull, creating a distinctive profile that was both beautiful and functional in ways that researchers would debate for decades. Some evidence suggested they served as resonating chambers that amplified vocalizations, allowing pack members to communicate across distances that would otherwise have prevented coordination of hunting activities. The structure of these crests was delicate compared to the massive bone ridges that characterized other crested dinosaurs. Yet their very fragility suggested purposes that extended beyond mere display or species recognition. The hollow spaces within the bone were connected to the nasal passages in ways that could have enhanced the creature's sense of smell, while the positioning and shape of the crests created acoustic properties that would have been ideal for producing the complex vocalizations that pack hunting required. Recent studies of the brain cases found within Dilophosaurus skulls revealed neural architecture that supported not only the enhanced sensory processing that the crests suggested, but also cognitive capabilities that exceeded those of most contemporary predators. The enlarged areas of the brain that govern social behavior and tactical planning indicated that these creatures possessed the intelligence necessary to coordinate complex group activities, while the regions responsible for learning and memory were developed to a degree that suggested individual personalities and accumulated experience that could be shared among pack members. The hunting strategies employed by Dilophosaurus packs were sophisticated affairs that took advantage of both the individual capabilities of pack members and the multiplicative effects of coordinated group action. Their preferred prey consisted primarily of the large herbivorous dinosaurs that dominated the early Jurassic landscape, creatures like Sauropelta and the early sauropods that possessed defensive capabilities that could prove dangerous to solitary predators but were vulnerable to the tactical approaches that pack hunting made possible. The attack pattern that Dilophosaurus groups employed began with careful observation and planning, as scouts would monitor potential prey from concealed positions while other pack members moved into strategic locations that would prevent escape once the assault commenced. The actual attack was typically initiated by the largest and most experienced member of the pack, whose charge would drive the prey toward the waiting ambush positions, where other pack members could strike at vulnerable flanks and hindquarters without exposing themselves to the defensive weapons that many herbivorous species had evolved. The killing bite of the Dilophosaurus was delivered not through the massive crushing jaws that characterized later tyrannosaurs, but through a more precise approach that targeted specific vulnerable areas where major blood vessels could be severed efficiently. The relatively narrow skull and sharp blade-like teeth were perfectly adapted for this surgical approach to predation, allowing the creature to inflict fatal wounds without engaging in the prolonged struggles that could result in injury to the predator or escape by the prey. Yet the Dilophosaurus was not merely a killing machine optimized for bringing down large prey, for fossil evidence suggested that these creatures possessed complex social behaviors that extended far beyond the immediate requirements of hunting and feeding. Bone beds containing multiple individuals showed patterns of injury and healing that indicated pack members cared for wounded companions, while the discovery of juvenile remains in close association with adults suggested extended parental care that lasted well beyond the period when young animals could hunt independently. The vocalizations that the distinctive crests made possible served not only tactical purposes during hunts, but also facilitated the complex social interactions that maintained pack cohesion across the territories that Dilophosaurus groups claimed as their own. These territories were vast affairs that encompassed hundreds of square miles of diverse habitat, from the river valleys where their preferred prey came to drink to the upland forests where pack members could retreat during the hottest parts of the day or when nursing young. The seasonal migrations that characterized many herbivorous species of the early Jurassic required Dilophosaurus packs to adapt their hunting strategies and territorial boundaries according to patterns that repeated annually yet varied enough to demand flexible responses based on current conditions, rather than rigid adherence to predetermined behaviors. The intelligence that this adaptability required was reflected in brain structures that supported not only tactical planning and social coordination, but also the long-term memory necessary to recognize and respond to environmental changes that might not be repeated for months or years. During the breeding season, which appeared to have been timed to coincide with the period of maximum prey abundance that followed the annual migrations, Dilophosaurus behavior became even more complex as individuals competed for mates while maintaining the pack cohesion necessary for successful hunting. The courtship displays that males performed involved elaborate vocalizations amplified by their distinctive crests, creating symphonies of sound that could be heard across vast distances and served to advertise both individual fitness and pack strength to potential rivals and mates. The nesting sites that Dilophosaurus females selected for their eggs were typically located in elevated areas that provided natural protection from flooding, while offering clear sight lines that allowed parents to detect approaching threats before they could endanger the vulnerable eggs or newly hatched young. These communal nesting grounds became the focal points of pack territory during the breeding season, with multiple females contributing eggs to shared nesting areas that could be defended more effectively through coordinated effort than through individual vigilance. The eggs themselves were elongated affairs, approximately 8 inches in length, with shells that were thicker than those of modern birds, yet possessed the flexibility necessary to accommodate the rapid growth that characterized dinosaur development. The incubation period lasted approximately 75 days, during which time the parents took turns maintaining optimal temperature and humidity conditions while remaining alert to the countless threats that could destroy an entire generation before it had the opportunity to hatch. The newly emerged Dilophosaurus chicks were precocial creatures that possessed the basic motor skills necessary for movement and feeding within hours of hatching, yet they remained dependent upon parental care and pack protection for the complex learning that would be required to master the hunting techniques and social behaviors that defined their species. The educational process that transformed helpless hatchlings into capable predators extended over several years and involved not only the parents but the entire pack community in a cooperative effort that ensured the survival and success of each new generation. The forests through which these ancient predators moved were vastly different from any woodland that modern eyes would recognize, dominated by conifers and ferns that created canopy conditions unlike anything in contemporary ecosystems. The understory was thick with cycads and other primitive plants that provided cover for both predators and prey, while the absence of flowering plants meant that the entire structure of plant communities was organized according to principles that had vanished from the earth by the end of the Cretaceous period. The climate in which the Dilophosaurus flourished was generally warmer and more humid than modern conditions, with seasonal variations that were less extreme than those that characterize contemporary temperate regions, yet still significant enough to influence the timing of migrations, breeding cycles, and territorial disputes. The higher atmospheric carbon dioxide levels that prevailed during the Jurassic period supported plant growth that was more luxurious than anything modern ecosystems could sustain, creating biomass densities that could support the large herbivore populations upon which predators like Dilophosaurus depended. The death of individual Dilophosaurus, whether from injury, disease, or old age, typically occurred in circumstances that prevented fossilization, as pack members often defended their fallen companions from scavengers until decomposition was too advanced to permit preservation. The rare specimens that did enter the fossil record were usually individuals who had died alone or in circumstances where pack intervention was impossible, meaning that the fossil evidence available to future paleontologists represented only a tiny fraction of the total population and might not accurately reflect the full range of variation that characterized the living species. Yet occasionally, circumstances would align in ways that preserved not just individual specimens but entire behavioral scenes frozen in stone, as flash floods or volcanic ash falls created conditions that captured predators and prey in the very moments of their final interactions. These death assemblages would provide future researchers with invaluable insights into hunting behaviors and pack dynamics that could never be inferred from isolated bones alone, while also demonstrating the complex ecological relationships that connected all members of Jurassic ecosystems in webs of interdependence and competition. The geological processes that would eventually preserve Dilophosaurus remains for human discovery were already at work during the creature's lifetime, as the rift valleys and inland seas that characterized early Jurassic geography created sedimentary environments where rapid burial and mineral replacement could transform bone into stone. The red sandstones of the Kayenta Formation, where the first Dilophosaurus fossils would eventually be found, were being deposited during this period as ancient river systems carried sediment from highland areas into lowland basins, where it accumulated in layers that recorded the passage of time with the precision of geological calendars. Among the countless creatures that lived and died during the Dilophosaurus's reign, one individual would eventually play a role that its kind could never have imagined. As a small mosquito drawn by the scent of fresh blood settled upon the flank of a recently killed prey animal and began to feed, the blood that this insignificant insect drew into its tiny body contained within it the complete genetic heritage of one of the most sophisticated predators that had yet appeared in the evolutionary history of life on Earth. Genetic information that would remain dormant within the mosquito's digestive system until it too met its fate. The amber that would preserve this mosquito and its precious cargo was forming even as the Dilophosaurus hunted through its ancient forests, as resin from primitive conifers hardened into translucent tombs that captured whatever touched them in crystalline perfection. The mosquito, heavy with its burden of dinosaur blood and the developing eggs within its body, became entangled in one such drop of resin as it sought shelter among the protective branches of an ancient tree, sealing within ambers. Embrace not only its own tiny form, but the genetic legacy of creatures whose magnificence would one day be both resurrected and diminished by the ambitions of beings that had not yet evolved. In the laboratories of San Diego, where the future of genetic engineering was being written in the sterile chambers and computer terminals of international genetic technologies, the amber-preserved mosquito that had fed upon Dilophosaurus blood 65 million years earlier was about to fulfill a destiny that neither evolution nor chance could have predicted. The year was 1985, and Dr. Henry Wu stood before extraction equipment that represented the culmination of decades of molecular biological research, preparing to attempt something that previous generations of scientists would have dismissed as impossible fantasy. The mosquito itself was a perfect specimen, its tiny form captured within the golden matrix of ancient tree resin, with such clarity that every detail of its anatomy remained visible to researchers who examined it through high-powered microscopes. The preservation was so complete that even the contents of its digestive system remained intact, protected from the forces of decay and chemical breakdown that had destroyed countless other sources of prehistoric genetic material. Within that microscopic stomach lay the blood cells of a creature that had been dead for longer than mammals had walked the earth. Wu's approach to extracting usable DNA from specimens of such extreme age required techniques that pushed the boundaries of existing molecular biology, as the genetic material that had survived the fossilization process was highly fragmented and degraded by millions of years of chemical breakdown and radiation damage. The polymerase chain reaction technology that made possible the amplification of tiny DNA samples was still in its experimental stages, requiring modifications and refinements that Wu's team developed through months of painstaking trial and error. The initial extraction attempts yielded genetic sequences that were tantalizingly incomplete, fragments of the Dilophosaurus genome that contained recognizable genes for basic physiological functions, but lacked the complete information necessary to direct the development of a living organism. These partial sequences revealed enough about the creature's biology to confirm that it was indeed a theropod dinosaur closely related to other carnivorous species. Yet the gaps in the genetic code were so extensive that conventional cloning techniques would have been impossible. Wu's solution to this fundamental challenge represented one of his most significant innovations in the field of genetic engineering, as he developed methods for using DNA from modern species to fill the gaps in ancient sequences, while preserving the essential characteristics that made each dinosaur species unique. The selection of appropriate donor organisms required extensive computer modeling and comparative genomic analysis, as Wu sought species whose genetic material would be compatible with Dilophosaurus DNA while avoiding combinations that might produce unstable or non-viable organisms. The discovery that certain amphibian species possessed genetic sequences that were remarkably similar to those found in the Dilophosaurus samples provided Wu with the breakthrough he needed to begin serious reconstruction work. African reed frogs, whose DNA had been shaped by evolutionary pressures that created remarkable adaptability and reproductive flexibility, proved to be ideal donors for filling gaps in the dinosaur genome, while introducing characteristics that would actually enhance the viability of cloned specimens. The decision to incorporate frog DNA into the Dilophosaurus genome was driven by practical considerations rather than scientific curiosity, yet it would prove to have consequences that extended far beyond Wu's immediate objectives. The amphibian genetic material provided not only the missing sequences necessary for basic cellular functions, but also introduced regulatory mechanisms that had never existed in dinosaur biology, creating hybrid organisms whose behavior and capabilities would differ from their ancient ancestors in subtle but significant ways. The first successful reconstruction of a complete Dilophosaurus genome required 18 months of intensive laboratory work, as Wu's team painstakingly assembled genetic sequences from hundreds of individual fragments, while ensuring that the resulting combination would be capable of directing normal embryonic development. The computer systems necessary for managing this level of genetic analysis were among the most advanced available, yet they operated at speeds that would seem glacial compared to the processing power that later generations of genetic engineers would take for granted. InGen's decision to establish dedicated breeding facilities on Ila Sorna reflected both the enormous costs involved in genetic reconstruction and the need for absolute secrecy during the most sensitive phases of the cloning program. The island location provided security that was impossible to achieve on the mainland, while the tropical climate closely approximated the environmental conditions that had characterized dinosaur habitats during the Mesozoic era. The construction of specialized laboratories and incubation facilities represented an investment of hundreds of millions of dollars in infrastructure that existed for the sole purpose of bringing extinct species back to life. The artificial wombs that would nurture the first Dilophosaurus embryos were technological marvels that recreated the conditions that had existed within dinosaur eggs millions of years earlier, maintaining precise temperature and humidity levels while providing the nutrients and oxygen necessary for normal development. These life support systems required constant monitoring and adjustment, as the embryos they contained followed developmental pathways that had never been documented by modern science and could not be predicted based on studies of contemporary species. The first Dilophosaurus embryo to achieve viability developed according to a timeline that closely matched estimates based on comparative studies of modern reptiles and birds. Yet the creature that emerged after 78 days of artificial incubation was unlike anything that Wu's team had expected based on their analysis of fossil evidence. The infant dinosaur was clearly a Dilophosaurus, possessing the distinctive cranial crests and body proportions that characterized the species, yet its size and behavior patterns differed significantly from what paleontological research had suggested. The newly hatched Dilophosaurus measured only 14 inches from nose to tail, making it substantially smaller than the 3-foot length that computer models had predicted based on the scaling relationships observed in modern animals. This discrepancy was initially attributed to the stress of artificial development and the hybrid nature of the creature's genetic structure, yet subsequent analysis revealed that Wu's genetic modifications had produced more extensive changes than he had anticipated when he began the reconstruction process. The behavioral characteristics that the infant Dilophosaurus displayed were equally unexpected, as the creature demonstrated levels of intelligence and social awareness that exceeded those observed in comparable modern reptiles, while also exhibiting traits that seemed more mammalian than reptilian in their expression. The young animal responded to human voices and movements with curiosity rather than fear, suggesting that its neural development had been influenced by the amphibian genetic material in ways that affected cognition and social behavior. Wu's initial assumption was that these unexpected characteristics would normalize as the creature matured and its behavior patterns stabilized according to the genetic programs encoded in its DNA. Yet careful observation revealed that the modifications he had introduced were producing permanent changes that would affect every aspect of the animal's biology. The decision to proceed with additional cloning attempts despite these uncertainties reflected both scientific curiosity and commercial pressure from InGen's leadership, who were eager to begin developing the dinosaur attractions that would justify their massive investments in genetic research. The second generation of Dilophosaurus clones, produced using refined techniques that Wu hoped would eliminate some of the unexpected characteristics observed in the first specimen, actually exhibited even more pronounced deviations from expected norms. These animals were not only smaller than their paleontological models predicted, but also displayed behavioral patterns that suggested their predatory instincts had been significantly modified by the genetic modifications that made their paleontological existence possible, rather than the aggressive pack-hunting behaviors that fossil evidence suggested had characterized the original Dilophosaurus. The cloned specimens demonstrated more cautious and opportunistic feeding strategies that relied upon scavenging and the capture of small prey rather than coordinated attacks upon large herbivores. This behavioral shift was initially viewed as a beneficial modification that would make the creatures more suitable for exhibition in controlled environments, yet it also represented a fundamental alteration of the species' ecological role and natural characteristics. Wu's analysis of the genetic mechanisms responsible for these behavioral changes revealed that the amphibian DNA sequences he had used to fill gaps in the Dilophosaurus genome had introduced regulatory elements that affected the expression of genes controlling aggression, territorial behavior, and social coordination. The resulting creatures possessed the physical characteristics of their ancient ancestors, but had been transformed into something that was neither truly dinosaur nor truly amphibian, but rather an entirely new category of organism that had never existed in nature. The implementation of the lysine contingency represented Wu's most controversial modification of the Dilophosaurus genome, as he introduced a genetic dependency that would ensure the creature's permanent reliance upon their human caretakers for survival. This artificial nutritional requirement was achieved by deleting the genes responsible for producing lysine, an essential amino acid that the animals would need to obtain from specially designed food supplements or genetically modified plants that would be available only within InGen's controlled environments. The lysine contingency was presented to InGen's leadership as an elegant solution to the problem of containment, ensuring that any creatures that escaped from designated areas would gradually weaken and die as their bodies depleted their lysine reserves. Yet Wu privately understood that this modification represented a fundamental violation of the creature's biological integrity, transforming magnificent predators into dependent organisms whose very existence was contingent upon human technological intervention. The psychological effects of these genetic modifications upon the cloned Dilophosaurus were subtle but profound. As creatures that should have possessed the confidence and territorial instincts of apex predators instead displayed behaviors that suggested uncertainty and social confusion. Their vocalizations, while recognizably similar to the calls that computer models predicted for the original species, lacked the complexity and communicative richness that pack hunting would have required, suggesting that their social intelligence had been compromised by the genetic tampering that had brought them back to life. Wu's attempts to address these behavioral anomalies through environmental enrichment and social conditioning met with limited success, as the fundamental modifications to the creature's neural development could not be overcome through training or experiential learning. The Dilophosaurus that emerged from his laboratories were physically healthy and capable of survival within controlled conditions. Yet, they were pale shadows of the magnificent predators whose genetic heritage they carried, diminished by human intervention in ways that no amount of scientific sophistication could fully remedy. The decision to maintain the reduced size characteristics that had emerged from Wu's genetic modifications was driven by practical considerations related to facility, construction costs, and visitor safety rather than scientific accuracy or respect for the creature's natural heritage. InGen's leadership recognized that smaller dinosaurs would be easier to contain, less expensive to maintain, and more suitable for the theme park environment that represented their ultimate commercial objective. The scaling down of the Dilophosaurus was accomplished through modifications to growth hormone regulation and metabolic programming that ensured the creatures would never achieve the impressive size that had characterized their ancient ancestors. These changes were implemented with the same clinical precision that Wu brought to all his genetic modifications, yet they represented perhaps the most significant departure from paleontological accuracy that the cloning program had yet attempted. The establishment of breeding populations on Isla Sorna proceeded according to carefully planned schedules that balanced the need for genetic diversity with the practical limitations imposed by the artificial nature of the creature's blockum reproductive biology. The lysine dependency that Wu had engineered into every specimen meant that breeding success was contingent upon maintaining constant supplies of nutritional supplements, while the behavioral modifications that affected social coordination created challenges for establishing the pair bonds that successful reproduction required. The first generation of naturally conceived Dilophosaurus offspring demonstrated that Wu's genetic modifications were indeed heritable, as the young animals displayed the same reduced size and modified behavior patterns that characterized their cloned parents. Yet, these naturally born specimens also exhibited subtle variations that suggested the artificial genetic combinations were beginning to express themselves in unpredictable ways, creating phenotypic diversity that had not been anticipated during the original cloning program. Wu's detailed documentation of every aspect of the Dilophosaurus breeding program created an invaluable database of information about the challenges and possibilities inherent in genetic resurrection. Yet, this scientific treasure trove was also a record of systematic manipulation that transformed authentic species into artificial constructs designed to serve human purposes, rather than express their own evolutionary heritage. Each successful birth was simultaneously a triumph of genetic engineering and a tragedy of biological authenticity lost to corporate ambition. The behavioral studies that Wu conducted during this period revealed that the cloned Dilophosaurus retained many of the cognitive capabilities that had made their ancestors successful predators, including problem-solving abilities, social recognition, and adaptive learning that allowed them to respond effectively to changing environmental conditions. Yet these abilities were expressed through behavioral patterns that bore little resemblance to the hunting strategies and territorial organization that had characterized the original species. The venom delivery system that had been one of the Dilophosaurus's most distinctive capabilities, posed particular challenges for Wu's genetic reconstruction efforts. As the fossil record provided limited information about the biochemical composition of prehistoric venoms or the physiological mechanisms that had produced and delivered these toxins, the decision to enhance rather than merely reproduce the creature's venomous capabilities reflected both scientific ambition and entertainment industry requirements for spectacular effects that would impress park visitors. Wu's analysis of modern venomous species provided templates for creating synthetic toxin combinations that would be both effective against potential prey and visually dramatic when deployed. Yet the artificial venoms he developed bore no relationship to whatever biochemical weapons the original Dilophosaurus might have possessed. These laboratory-created toxins were designed to cause rapid paralysis and disorientation without permanent injury, making them suitable for controlled exhibition environments while preserving the creature's fearsome reputation. The dilating hood mechanism that became one of the most recognizable features of InGen's Dilophosaurus was entirely Wu's invention, created through modifications to neck musculature and integumentary structures that had no basis in fossil evidence or paleobiological research. This theatrical enhancement was designed to provide visual warning of impending venom attacks, while also creating the dramatic spectacle that theme park audiences would expect from encounters with prehistoric predators. The artificial nature of these modifications meant that the Dilophosaurus that emerged from Wu's laboratories were essentially special effects creatures rather than authentic resurrections of ancient species. Yet the sophistication of their genetic engineering made them convincingly organic in their appearance and behavior patterns. The distinction between recreation and creation had become so blurred that even Wu himself sometimes struggled to remember which characteristics were based on scientific evidence and which were products of his own imagination and commercial requirements. The establishment of containment protocols for the modified Dilophosaurus required extensive behavioral analysis and environmental testing, as the creature's reduced aggression and modified hunting instincts created security challenges that differed significantly from those that would be posed by authentic prehistoric predators. The artificial nature of their dependencies and behavioral patterns made them more predictable than their ancient ancestors would have been. Yet it also created vulnerabilities that could be exploited by individuals who understood the genetic modifications that constrained their capabilities. As the Dilophosaurus breeding program matured and began producing stable populations that could support the commercial operations planned for Jurassic Park, Wu reflected upon the compromises and modifications that had made this success possible. The creatures that bore the name and general appearance of one of the Jurassic period's most successful predators were remarkable achievements of genetic engineering. Yet they were also monuments to humanity's inability to resist the temptation to improve upon natural designs that had achieved perfection through millions of years of evolutionary refinement. The legacy of Wu's work with the Dilophosaurus would extend far beyond the specific creatures he had created, establishing precedents and methodologies that would influence every subsequent genetic resurrection project that InGen undertook. Yet this legacy was fundamentally ambiguous, representing both the heights of scientific achievement and the depths of scientific arrogance. As humanity demonstrated its power to bring back the dead, while simultaneously revealing its inability to resist the urge to remake ancient life, according to modern prejudices and commercial requirements. In the spring of 1993, when the towers of Jurassic Park rose like temples to human achievement against the tropical sky of Isla Nublar, and the dream of controlled resurrection seemed finally within reach of fulfillment, the modified Dilophosaurus that Dr. Henry Wu had crafted in his laboratories was about to play a role that would transform it from curious exhibit into symbol of corporate hubris brought low by forces that no amount of planning could anticipate or control. The creature that awaited its moment in the shadowed paddocks of the island paradise bore only superficial resemblance to the magnificent predator, whose genetic heritage had been filtered through Wu's modifications and commercial requirements. The Dilophosaurus, designated as Specimen 7 by InGen's taxonomic system, had been selected for transport to Isla Nublar based upon behavioral assessments that suggested it possessed the optimal combination of docility and dramatic potential that Hammond's vision required. At 7 feet in length and weighing approximately 400 pounds, the creature was substantially smaller than paleontological evidence suggested the original species had achieved. Yet, its distinctive cranial crests and the theatrical modifications that Wu had engineered into its anatomy made it an impressive representative of prehistoric predation, adapted for modern entertainment purposes. The paddock that had been constructed to house the Dilophosaurus reflected both InGen's commitment to creating naturalistic environments and their fundamental misunderstanding of the creature they were attempting to contain. The enclosure featured dense vegetation that approximated early Jurassic forest conditions, complete with primitive conifers and fern understories that had been cultivated specifically to provide authentic visual settings for visitor encounters. Yet, the barriers that separated this artificial wilderness from the outside world were designed according to principles that assumed the inhabitants would behave according to the modified behavioral patterns that Wu's genetic engineering had supposedly programmed into their neural development. The electronic fencing system that formed the primary containment mechanism relied upon mild electrical charges that were calibrated to deter escape attempts without causing permanent injury to creatures whose welfare had become a matter of considerable corporate investment. These barriers were supplemented by motion sensors and infrared monitoring equipment that provided constant surveillance of the paddock's inhabitant, while automated feeding systems delivered specially formulated nutrients that satisfied both the creature's dietary requirements and the lysine dependency that Wu had engineered into its genetic structure. Dennis Nedry's arrival on Isla Nublar in the weeks preceding the park's planned opening had been motivated by financial desperation and corporate resentment, rather than any scientific curiosity about genetic resurrection. Yet his position as the architect of the island's computer systems placed him at the center of every operation that required electronic coordination or automated control. His intimate knowledge of the programming that governed everything from door locks to feeding schedules made him uniquely capable of manipulating the park's infrastructure in ways that its designers had never anticipated or prepared. To counter, the arrangement that Nedry had negotiated with Dr. Louis Dodgson of the Biosyn Corporation represented industrial espionage on a scale that could potentially shift the balance of power in the emerging field of genetic engineering, as the theft of viable embryos would provide Biosyn with access to technologies that they had been unable to develop through their own research programs. The price that Biosyn was willing to pay for such samples reflected both the commercial value of InGen's achievements and the lengths to which competitors would go to acquire proprietary genetic material that could not be obtained through legal means. The modified briefcase that would serve as a portable incubation system for the stolen embryos represented a masterpiece of miniaturized life support technology, capable of maintaining viable biological samples for the extended periods that would be required to transport them from Isla Nublar to mainland laboratories where they could be analyzed and reproduced. The device's innocuous appearance concealed sophisticated environmental controls and power systems that would ensure sample viability even under adverse conditions, while its disguise as ordinary luggage would allow Nedry to remove the embryos from the island without arousing suspicion from security personnel who were focused on preventing unauthorized access rather than detecting unauthorized departures. The tropical storm that approached Isla Nublar on the evening of Nedry's planned theft seemed like a minor complication compared to the sophisticated preparation that had gone into planning the operation. Yet it would prove to be the catalyst that transformed a carefully orchestrated crime into a catastrophic breakdown of every system that InGen had relied upon to maintain order and safety throughout their island paradise. The decision to reduce staff levels and suspend routine operations during the storm created the perfect conditions for Nedry to implement his plan, without interference from colleagues whose presence might complicate his access to restricted areas. The activation of Nedry's virus at precisely 11:18 in the evening triggered a cascade of system failures that extended far beyond the programmer's intended objectives, as the malicious code he had inserted into the park's computer networks interacted with security protocols and automated systems in ways that created unpredictable and dangerous conditions throughout the facility. The selective shutdown of security barriers that was supposed to provide Nedry with access to the embryo storage facility also disabled containment systems that were never intended to be compromised, while the communication failures that concealed his activities from park management also prevented rapid response to the emergencies that his sabotage created. The Dilophosaurus that emerged from its suddenly inert paddock into the storm-lashed night was confronted with freedom that it had never experienced and environmental conditions that triggered behavioral responses that WOO's laboratory studies had never documented or anticipated. The creature's modified neural architecture, designed to produce docility and dependency within controlled environments, proved inadequate for processing the complex stimuli and decision-making challenges that liberation from artificial constraints presented, creating psychological stress that manifested itself through increasingly erratic and unpredictable behavior patterns. The rain that drove across the island in sheets made navigation difficult for human and dinosaur alike. Yet the Dilophosaurus possessed sensory capabilities that had been enhanced rather than diminished by WOO's genetic modifications, allowing it to detect chemical traces and electromagnetic signatures that provided information about its environment that vision alone could never have supplied. The creature's distinctive crests, which had been modified to serve as resonating chambers for the theatrical vocalizations that park visitors expected, also functioned as sophisticated sensory organs that could detect minute changes in air pressure and humidity that preceded shifts in weather patterns. Dennis Nedry's frantic rush through the darkened park toward the embryo storage facility was guided by intimate knowledge of the island's layout and infrastructure, yet his familiarity with computer systems and electronic controls had not prepared him for navigating physical terrain under conditions where normal landmarks were obscured by darkness and driving rain. The handheld GPS unit that should have provided precise positional information was interfering with the same communication systems that his virus had compromised, creating navigation challenges that transformed a routine journey into a desperate struggle against both natural and artificial obstacles. The encounter between Nedry and the Dilophosaurus occurred not through any predatory stalking behavior that might have characterized the creature's ancient ancestors, but rather through the random intersection of two individuals who were both struggling to adapt to circumstances that neither their evolutionary heritage nor their technological preparation had equipped them to handle effectively. The programmer's theft of the embryos had been completed successfully, yet his escape from the island was being hampered by the same system failures that had made the theft possible, while the dinosaur's liberation from its paddock had provided freedom for which its modified behavioral programming had left it fundamentally unprepared. The Dilophosaurus that confronted Nedry beside his disabled vehicle was a creature caught between its authentic genetic heritage and the artificial modifications that WOO's engineering had imposed upon its neural development. resulting in behavioral patterns that combined elements of natural predatory instincts with responses that had been shaped by months of conditioning within controlled environments. The theatrical modifications that had been designed to enhance the creature's entertainment value transformed what might have been a straightforward predatory encounter into something that more closely resembled performance art, as the animal's dilating hood and preparatory vocalizations provided dramatic warning of impending attack. Yet the attack that followed was not the swift, efficient killing that characterized natural predation, but rather a prolonged assault that reflected both the creature's confusion about appropriate behavioral responses and the artificial nature of the venom delivery system that Wu had engineered to provide spectacular effects rather than practical hunting capabilities. The synthetic toxins that the Dilophosaurus delivered through its modified bite were designed to cause rapid paralysis and disorientation, while maintaining victim consciousness long enough to appreciate the full horror of their situation, creating experiences that were fundamentally different from anything that natural venoms would have produced. The agony that Nedry experienced as the artificial venoms began to affect his nervous system was unlike anything that medical science had documented, as the laboratory-created toxins combined effects that had never existed in natural predatory relationships. His vision failed, not through the straightforward neural disruption that snake venoms typically produced, but through a complex cascade of neurochemical reactions that created hallucinations and perceptual distortions that transformed his final moments into a nightmare that exceeded even his worst. Fears about genetic resurrection gone wrong. The blindness that overtook Nedry was accompanied by auditory hallucinations that made it impossible for him to determine whether the sounds he heard represented actual environmental stimuli or products of his poisoned nervous system's increasingly chaotic functioning. The hooting calls that the Dilophosaurus produced through its modified vocal apparatus were amplified and distorted by the creature's cranial crests, until they seemed to come from multiple directions simultaneously, creating acoustic effects that no natural predator had ever achieved, and that human hearing was not equipped to process correctly. The discovery of Nedry's remains by park security teams hours later revealed the extent to which Wu's modifications had transformed even the feeding behaviors of his resurrected creatures, as the Dilophosaurus had consumed its victim in patterns that bore no resemblance to the efficient processing that characterized natural predation. The artificial nature of the creature's hunting instincts had resulted in feeding behaviors that seemed designed more for psychological impact than nutritional efficiency, creating a crime scene that traumatized even experienced personnel who had witnessed the aftermath of other dinosaur attacks. The investigation that followed Nedry's death was hampered by the same system failures that had made his theft possible, as the security recordings and environmental monitoring data that might have provided detailed documentation of the encounter had been corrupted by the virus that the programmer had introduced into the park's computer networks. The partial information that investigators were able to recover painted a disturbing picture of predatory behaviors that differed significantly from those that Wu's behavioral studies had predicted, suggesting that the genetic modifications that had created the Dilophosaurus had also introduced unpredictable elements that rendered all previous safety assessments invalid. The embryo storage container that Nedry had died attempting to transport to his escape vehicle was recovered intact, its sophisticated life support systems having maintained sample viability despite the traumatic circumstances that had prevented its delivery to Biosyn representatives. The irony that the programmer's death had ultimately protected InGen's proprietary genetic material from theft was lost on corporate executives who were more concerned with the liability implications of having an employee killed by one of their own creations than with the industrial, espionage that his death had prevented. The cleanup operations that followed the storm required specialized teams trained in hazardous biological material handling, as the Dilophosaurus that had killed Nedry remained at large somewhere on the island and posed continuing threats to personnel who might encounter it during their duties. The creature's artificial venom delivery system made it more dangerous than its ancient ancestors had been, while its modified behavioral patterns made its actions unpredictable according to any models that researchers had developed for managing prehistoric predators. The psychological impact of Nedry's death upon InGen's staff extended far beyond immediate concerns about personal safety, as employees who had viewed the genetic resurrection program as humanity's greatest scientific achievement were forced to confront the reality that their creations were neither the docile attractions that marketing materials promised, nor the magnificent creatures whose natural heritage they supposedly represented. The hybrid nature of Wu's organisms made them fundamentally alien to both ancient ecosystems and modern environments, creating beings that belonged fully to neither world and posed unique dangers that no previous experience had prepared anyone to handle. John Hammond's response to the crisis reflected both his visionary optimism and his dangerous inability to acknowledge the fundamental flaws in his approach to genetic resurrection, as he sought to minimize the incident's significance while simultaneously implementing security measures that tacitly acknowledged the inadequacy of existing containment protocols. The contradiction between his public statements about dinosaur safety and his private authorization of lethal response procedures revealed the extent to which commercial pressures had corrupted his scientific judgment and moral reasoning. The cover-up that followed Nedry's death involved cooperation between InGen's corporate hierarchy, governmental regulatory agencies, and international organizations whose interests were served by maintaining public confidence in genetic resurrection technologies, despite clear evidence that such confidence was misplaced. The official reports that described Nedry's death as an accident involving conventional wildlife reflected both institutional incompetence and deliberate deception, as authorities proved more committed to protecting corporate interests than to acknowledging the genuine dangers that genetic engineering had created. The Dilophosaurus that had killed Nedry was eventually recaptured through the use of tranquilizer weapons and specialized tracking equipment. Yet the creature's behavior, during the days it remained at large, provided disturbing evidence that Wu's genetic modifications were continuing to express themselves in unpredictable ways. The animal's movements through the island's infrastructure showed problem-solving capabilities and environmental adaptation that exceeded anything that laboratory studies had suggested, while its apparent attraction to artificial light sources and electronic equipment suggested neural modifications that had created entirely new categories of behavioral responses. The decision to maintain the Dilophosaurus in captivity rather than destroying it reflected both scientific curiosity about the creature's unique characteristics and commercial calculations about the value of preserving specimens that represented millions of dollars in research and development costs. The enhanced security measures that surrounded its new containment facility acknowledged that Wu's creation posed dangers that standard zoological protocols were inadequate to address, while the restricted access that prevented direct observation by unauthorized personnel ensured that the full extent of the creature's artificial modifications would remain hidden from public scrutiny. Dr. Wu's analysis of the incident revealed that the genetic modifications he had introduced into the Dilophosaurus genome had interacted with stress hormones and environmental stimuli in ways that activated dormant behavioral patterns that his laboratory studies had never encountered. The artificial nature of the creature's neural architecture meant that exposure to novel situations could trigger responses that had no basis in either natural evolution or intended programming, creating possibilities for behavior that no amount of preparation or training could anticipate or prevent. The broader implications of Nedry's death for InGen's genetic resurrection program were largely ignored by corporate leadership, who viewed the incident as an isolated failure of security protocols, rather than evidence of fundamental problems with the entire approach to creating and managing artificial organisms. The modifications that Wu had made to address commercial and entertainment requirements had transformed authentic species into creatures that were neither natural nor truly artificial, but rather hybrid beings that possessed the worst characteristics of both categories while lacking the stabilizing influences that millions of years of evolutionary development had provided. The legacy of Dennis Nedry's encounter with Wu's modified Dilophosaurus would extend far beyond the immediate crisis it created, establishing precedents for corporate liability and regulatory oversight that would influence every subsequent genetic engineering project. Yet, the most significant consequence of the incident was its demonstration that the technologies of genetic resurrection could not be controlled or predicted through conventional scientific methods, as the artificial organisms they created possessed emergent characteristics that transcended the intentions of their creators and the limitations that supposedly constrained their behavior. In the deep places where corporate memory preserved the details of industrial accidents and liability assessments, Nedry's death became a footnote in reports that emphasized procedural failures rather than fundamental philosophical problems with genetic resurrection. The programmer who had died attempting to steal embryos worth millions of dollars was remembered not as a victim of scientific hubris, but as a criminal whose greed had led to his own destruction, while the creature that had killed him was viewed as a valuable asset whose behavioral anomalies required better management, rather than questions about the ethics of creating artificial life forms designed to serve commercial rather than scientific purposes. In the aftermath of Jurassic Park's catastrophic collapse, when the dream of controlled resurrection had been shattered by forces that no amount of corporate planning could contain, and the abandoned facilities of Isla Nublar stood as monuments to human hubris, brought low by prehistoric power, the true laboratory of genetic resurrection continued its work in the hidden valleys of Isla Sorna, where creatures freed from human management began to explore the possibilities and limitations of artificial existence in ways that their creators had never anticipated or intended. Site B, as InGen's corporate documents had designated the island with bureaucratic precision that masked its revolutionary significance, had been transformed by the absence of human oversight into something that more closely approximated natural ecosystems than any controlled environment that genetic engineers had previously attempted to create. The Dilophosaurus populations that had been established there during the years of intensive breeding programs found themselves confronted with challenges and opportunities that bore no resemblance to the sanitized conditions of laboratory, incubators, or the carefully managed environments of exhibition paddocks. The modified creatures that Dr. Wu had crafted in his laboratories possessed genetic architectures that had never been tested by the rigorous selection pressures of natural evolution, yet their release into uncontrolled conditions provided the first opportunity to observe how artificial organisms might adapt to environmental challenges that their creators had not anticipated when designing their hybrid genomes. The behavioral modifications that had been intended to produce docility and dependency within human-managed systems proved to be either inadequate or counterproductive when applied to survival situations that required initiative and adaptability rather than compliance with predetermined routines. The pack dynamics that emerged among the liberated Dilophosaurus differed significantly from both the social structures that paleontological evidence suggested had characterized their ancient ancestors, and the simplified behavioral patterns that Wu's conditioning programs had attempted to establish during their laboratory development. These artificial creatures, possessing neither the evolutionary heritage that had shaped natural predatory societies, nor the environmental consistency that had defined their captive experience, were forced to create entirely new forms of social organization that drew upon genetic memories modified by artificial constraints and immediate survival requirements that transcended any theoretical framework. The first generation of naturally conceived offspring to reach maturity within Site B's uncontrolled environment displayed characteristics that their laboratory-born parents had never exhibited, as exposure to variable environmental conditions triggered gene expression patterns that Wu's controlled studies had never documented. These young Dilophosaurus were simultaneously more and less than their genetic programming had intended, possessing capabilities that exceeded their parents' artificial limitations, while also displaying vulnerabilities that resulted from the inherent instabilities of hybrid genomes that had never been subjected to the stabilizing influences of natural selection. The venom delivery systems that Wu had engineered to provide theatrical effects suitable for theme park exhibitions proved to be remarkably effective weapons when deployed in genuine survival situations, yet their artificial nature created chemical compositions that had unpredictable effects upon the diverse prey species that populated Illa Sorna's ecosystems. The synthetic toxins that had been designed to cause controlled paralysis and disorientation in human subjects produced entirely different reactions when introduced into the physiological systems of other dinosaur species, creating ecological relationships that had never existed in natural environments and could not be predicted based on any known biological precedents. The modified cranial crests that gave the Dilophosaurus their distinctive appearance continued to function as resonating chambers for complex vocalizations. Yet, the communications that emerged from these artificially enhanced structures bore little resemblance to either the simple calls that Wu's laboratory studies had documented or the sophisticated pack coordination signals that fossil evidence suggested had characterized their ancient ancestors. The hybrid nature of their neural architecture had created communication capabilities that were simultaneously more complex and less effective than those of natural species, resulting in social coordination that was adequate for basic survival, yet lacked the precision and reliability that successful pack hunting required. The territorial boundaries that Dilophosaurus groups established across Site B's diverse habitats reflected both the reduced aggression that Wu's modifications had programmed into their behavioral repertoires and the practical limitations imposed by their artificial dependencies upon specific environmental conditions that had to be maintained through conscious effort rather than instinctive adaptation. These territories were smaller and more carefully managed than paleontological evidence suggested their ancestors had claimed, yet they were also more complex in their internal organization, as the creatures had learned to create microenvironments that satisfied their hybrid physiological requirements. The hunting strategies that evolved among Site B's Dilophosaurus populations represented attempts to adapt natural predatory behaviors to the constraints and capabilities that genetic modification had imposed upon their physical and mental characteristics, rather than the coordinated pack attacks that had made their ancestors successful apex predators. These artificial creatures developed opportunistic feeding patterns that relied heavily upon scavenging and the exploitation of prey species that were already weakened by disease, injury, or environmental stress. The discovery of these modified hunting behaviors by InGen's monitoring teams provided the first concrete evidence that genetic resurrection had created organisms whose ecological roles differed fundamentally from those of their supposed historical templates. The creatures that bore the name Dilophosaurus were clearly related to their ancient predecessors, yet their artificial modifications had transformed them into something that occupied an entirely different niche within the complex web of interactions that characterized living ecosystems. Dr. Martin Gutierrez's encounters with Dilophosaurus specimens during his research expeditions to Costa Rica's mainland provided disturbing evidence that Wu's creatures had not remained confined to their designated island habitats but had somehow established populations in regions where their presence posed threats to both native wildlife and human communities. The attacks upon local children that Gutierrez documented bore the distinctive characteristics of Dilophosaurus venom, yet the behavioral patterns associated with these incidents suggested that the creatures responsible had developed hunting strategies that were specifically adapted for targeting human prey. The investigation that followed these mainland sightings revealed that several Dilophosaurus specimens had escaped from Site B during storm conditions that temporarily compromised the containment barriers that were supposed to prevent unauthorized movement between islands. These escapees had successfully navigated oceanic distances that should have been impossible for creatures whose genetic modifications had supposedly rendered them dependent upon artificial life support systems, demonstrating that Wu's organisms possessed adaptive capabilities that their creators had neither intended nor anticipated. The establishment of breeding populations on the Costa Rican mainland represented the first clear failure of the containment strategies that had been designed to prevent genetic contamination of natural ecosystems by artificially created organisms. The hybrid nature of the escaped Dilophosaurus made them capable of surviving in environments that differed significantly from their original island habitats, while their modified behavioral patterns allowed them to avoid detection by wildlife management authorities who lacked experience with creatures whose characteristics fell outside the parameters of conventional zoological knowledge. Roland Tembo's species profiles, compiled during his preparation for the InGen harvesting expedition that would eventually transport captured dinosaurs to the mainland United States, included detailed observations of Dilophosaurus behavior that contradicted many of the assumptions that had guided Wu's original genetic modifications. Tembo's field notes described creatures whose size varied considerably among individuals, with some specimens approaching the 20-foot lengths that paleontological evidence suggested had characterized their ancient ancestors, while others remained limited to the reduced dimensions that Wu's programming had imposed. This size variation among supposedly identical genetic constructs provided evidence that the environmental conditions prevailing on Site B were triggering expression patterns that laboratory studies had never documented, as some individuals were apparently overcoming the growth limitations that had been engineered into their genomes, while others remained constrained by the artificial restrictions that Wu had intended to be permanent features of their biology. The mechanisms responsible for these variations remained unclear, yet their existence demonstrated that genetic modification was not the precise and predictable process that InGen's marketing materials had claimed. The behavioral documentation that Tembo compiled revealed that Site B's Dilophosaurus had developed complex social hierarchies based not upon the size or physical prowess that typically determined dominance relationships among natural predators, but upon factors that seemed to reflect their artificial origins and modified neural architectures. Leadership roles within packs were often assumed by individuals who displayed superior problem-solving abilities or enhanced communication skills, rather than those who possessed the most impressive physical characteristics, creating social structures that were unique among known predatory species. The hunting techniques that Tembo observed during his surveillance of Dilophosaurus packs demonstrated that these creatures had learned to exploit the artificial nature of their own construction in ways that provided tactical advantages unavailable to natural predators. Their synthetic venom delivery systems could be controlled with precision that allowed for graduated responses to different threat levels, while their modified vocalizations enabled forms of psychological manipulation that their ancient ancestors had never possessed. Yet these artificial advantages came at costs that became apparent when the creatures were forced to compete with natural species that had been shaped by millions of years of environmental selection rather than human design preferences. The Dilophosaurus that Tembo studied were effective predators within the limited contexts for which they had been designed, yet they struggled to adapt to environmental challenges that fell outside the parameters of their original programming, demonstrating the fundamental limitations inherent in organisms created through technological intervention rather than evolutionary development. The specimen that Tembo designated as Alpha 7 displayed characteristics that suggested it had somehow overcome many of the behavioral limitations that Wu had programmed into the Dilophosaurus genome, exhibiting levels of aggression and territorial behavior that more closely resembled natural predatory patterns than the modified responses that characterized most of its companions. This individual's behavior provided tantalizing hints about what authentic Dilophosaurus might have been like before human genetic modification had diminished their capabilities to serve commercial and safety requirements. The territorial conflicts that erupted between Alpha 7 and other pack members revealed the extent to which Wu's modifications had created internal contradictions within the creature's behavioral programming, as individuals who possessed more natural predatory instincts found themselves at odds with those whose artificial conditioning prevented them from responding appropriately to competitive challenges. These conflicts often resulted in permanent injuries that weakened entire packs and reduced their effectiveness as hunting units, demonstrating how genetic modification had introduced instabilities that natural evolution would never have tolerated. The feeding behaviors that Tembo documented showed that Site B's Dilophosaurus had developed preferences for prey species that possessed characteristics similar to their own artificial modifications, suggesting that they recognized kinship with other genetically manipulated organisms that shared their hybrid nature. This selective predation created ecological pressures that affected the entire dinosaur community on the island, as naturally evolved species found themselves competing for resources with creatures whose artificial advantages gave them unfair competitive benefits. The reproductive cycles that governed Dilophosaurus breeding on Site B differed significantly from the patterns that Wu's laboratory studies had established, as environmental variables that had never existed in controlled conditions triggered hormonal responses that modified both the timing and the success rates of natural conception. The artificial modifications that had been intended to ensure reproductive dependence upon human management proved inadequate when confronted with the complex chemical and social stimuli that characterized genuinely wild environments. The nesting behaviors that emerged among Site B's populations reflected attempts to adapt natural parental instincts to the constraints imposed by artificial genetic modifications and the environmental challenges that the island's uncontrolled conditions presented. The communal nesting sites that some packs established represented innovations that had no precedent in either paleontological evidence or behavioral studies of modern reptilian species, suggesting that the hybrid nature of these creatures was generating entirely new categories of social and reproductive behavior. The mortality rates among juvenile Dilophosaurus born in Site B's wild conditions exceeded those recorded in laboratory breeding programs. Yet the survivors displayed enhanced capabilities and reduced dependencies that suggested natural selection was beginning to operate upon Wu's artificial genetic constructs in ways that eliminated the most dysfunctional aspects of their hybrid inheritance. This evolutionary pressure represented both hope for the long-term viability of resurrected species and evidence that genetic modification could not permanently override the fundamental principles that governed biological systems. The San Diego incident that brought InGen's operations to public attention included several encounters with Dilophosaurus specimens that demonstrated how completely these creatures had adapted to environments and situations that their original programming had never contemplated. The urban setting that should have overwhelmed creatures designed for controlled exhibition environments instead provided new opportunities for the deployment of artificial capabilities that proved surprisingly effective when applied to challenges that modern cities presented. The psychological impact of these encounters upon civilian populations revealed that Wu's theatrical modifications had indeed created creatures whose appearance and behavior were optimally designed to inspire fear and fascination in human observers. Yet the artificial nature of these characteristics made the resulting terror somehow more disturbing than encounters with natural predators would have been. The uncanny valley effect that resulted from observing creatures that were simultaneously familiar and alien created lasting psychological trauma that conventional therapeutic approaches were inadequate to address. Peter Ludlow's corporate response to the evidence of Dilophosaurus adaptation and evolution on Site B reflected both recognition that Wu's creations had transcended their original limitations and determination to exploit these developments for commercial purposes that would restore InGen's financial viability. The harvesting operations that he authorized were designed not merely to capture individual specimens, but to document and potentially reproduce the environmental conditions that had triggered enhanced capabilities among wild populations. The capture techniques that were employed during these operations revealed how completely human understanding of these creatures remained limited by assumptions about their artificial nature and supposed limitations, as standard animal handling procedures proved inadequate for managing organisms whose behaviors combined natural predatory instincts with artificial modifications that had never been tested under genuine field conditions. The resulting injuries and escapes that characterized the harvesting efforts demonstrated that genetic resurrection had created new categories of danger that existing safety protocols were inadequate to address. The transportation of captured Dilophosaurus specimens to mainland facilities provided researchers with their first opportunities to conduct detailed comparative studies of creatures that had spent years adapting to uncontrolled conditions versus those that had remained within managed environments throughout their lives. These comparisons revealed that environmental exposure had triggered genetic expressions that laboratory conditions had never activated, suggesting that Wu's modifications had included dormant capabilities that were revealed only when creatures were forced to confront genuine survival challenges. The behavioral assessments that were conducted during this period showed that Site B specimens possessed problem-solving abilities and environmental awareness that exceeded those of their laboratory-raised counterparts by significant margin, yet they also displayed psychological characteristics that reflected the trauma and stress associated with survival in conditions for which their artificial genetics had not adequately prepared them. The resulting behavioral patterns were complex amalgamations of enhanced capabilities and psychological damage that defied conventional understanding of animal psychology and learning. The genetic analyses that were performed upon Site B specimens revealed that their DNA had remained stable despite years of exposure to environmental conditions that should have caused degradation in artificially constructed genomes. Yet subtle mutations had occurred that suggested the organisms were beginning to evolve beyond their original parameters in ways that could not be predicted or controlled through technological intervention. These evolutionary changes represented both encouraging evidence of biological resilience and disturbing proof that genetic modification could not permanently constrain the fundamental drives that governed living systems. The pathological studies that examined deceased Site B specimens showed that the lysine dependency that Wu had engineered into their metabolic systems had been partially overcome through dietary adaptations that allowed the creatures to wind on, extract essential amino acids from prey species that were unavailable within controlled environments. This nutritional independence represented the first clear evidence that genetic modification could be overcome through natural adaptation when organisms were provided with appropriate environmental pressures and sufficient time for evolutionary responses to develop. The implications of these discoveries for InGen's broader genetic resurrection program were largely ignored by corporate leadership, who remained focused upon commercial applications rather than scientific understanding of the biological processes they had unleashed. The evidence that artificial organisms could adapt and evolve beyond their original programming challenged fundamental assumptions about the predictability and controllability of genetic engineering, yet these challenges were viewed as management problems rather than indications of flawed theoretical foundations. In the deep places where corporate memory preserved the technical documentation of genetic engineering successes and failures, the records of Site B's wild Dilophosaurus populations remained classified as proprietary information, despite their implications for scientific understanding of evolution, adaptation, and the long-term consequences of genetic modification. The creatures that had transcended their artificial origins to become something unprecedented in the history of life on Earth were reduced to patent filings and liability assessments, while their achievements in overcoming human-imposed limitations were documented primarily as evidence of inadequate containment protocols rather than testimony to the resilience and adaptability of life itself. In the year 2005, when the world had begun to forget the lessons of Jurassic Park's catastrophic failure and corporate memory had transformed disaster into opportunity through the alchemy of selective recollection and strategic amnesia, Simon Masrani stood before the abandoned ruins of John Hammond's dream and envisioned something far more ambitious than mere restoration of what had been lost. The acquisition of InGen's assets by Masrani Global Corporation represented not simply a change in ownership, but a fundamental transformation in philosophy, as the telecommunications magnate brought to genetic resurrection an approach that prioritized spectacular entertainment over scientific authenticity and commercial success over respectful stewardship of resurrected life. The Dilophosaurus specimens that had survived the original park's collapse and the subsequent years of institutional neglect were discovered by Masrani's advanced teams in conditions that bore no resemblance to the carefully controlled environments that Dr. Wu's original protocols had specified. These creatures, descendants of the modified organisms that had been crafted to serve Hammond's vision of prehistoric exhibition, had adapted to abandoned facilities and overgrown habitats in ways that demonstrated both the resilience of artificial life and the inadequacy of human attempts to predict or control the long-term consequences of genetic manipulation. Dr. Henry Wu's return to active participation in genetic resurrection came not through scientific curiosity about the evolutionary adaptations that his creatures had achieved during their years of independence, but through corporate recruitment that appealed to his professional vanity and offered resources that exceeded anything his previous research had enjoyed. The aging geneticist brought to Masrani's project both the institutional memory necessary to understand what had been attempted before and the accumulated wisdom to recognize what modifications would be required to serve the new vision that corporate leadership had conceived. The decision to maintain the reduced size characteristics that had emerged from Wu's original modifications was driven by considerations that extended far beyond scientific accuracy or respect for paleontological evidence. As Masrani's entertainment industry background had taught him that audience engagement was more important than historical authenticity when creating experiences that would generate the revenue streams necessary to justify massive infrastructure investments. The Dilophosaurus that would populate Jurassic World would be designed not to recreate the majesty of their ancient ancestors, but to provide thrills and excitement for visitors whose expectations had been shaped by decades of monster movies and theme park attractions. The genetic modifications that Wu implemented during this second phase of his career represented a complete departure from the careful balance between authenticity and practicality that had characterized his earlier work as commercial pressures and entertainment industry requirements transformed scientific research into something that more closely resembled special effects creation than serious biological investigation. The creatures that emerged from his laboratories bore the distinctive appearance of Dilophosaurus, yet possessed behavioral characteristics and physiological capabilities that had been designed to maximize their value as interactive entertainment rather than preserve their scientific or historical significance. The holographic displays that formed the centerpiece of Jurassic World's educational presentations featured Dilophosaurus specimens that were portrayed according to theatrical interpretations rather than paleontological evidence, as marketing departments determined that dramatic effect was more valuable than scientific accuracy when creating content designed to prepare visitors for encounters with living specimens. These digital reconstructions established expectations and assumptions about dinosaur behavior that bore no relationship to either authentic prehistoric ecology or the actual characteristics of Wu's genetically modified creatures. The Innovation Center that housed these educational exhibits was designed to create an atmosphere of scientific legitimacy that concealed the extent to which commercial considerations had corrupted every aspect of the genetic resurrection program, as visitors were provided with carefully curated information that emphasized the wonder of bringing extinct species back to life, while omitting any discussion of the modifications and compromises that had been necessary to transform dangerous predators into manageable attractions. Mr. DNA, the animated mascot that explained genetic engineering concepts to park visitors, presented Wu's work as straightforward scientific achievement, rather than acknowledging the complex ethical and biological challenges that artificial resurrection had created. The simplified explanations that this cartoon character provided were designed to inspire confidence and excitement, rather than promote genuine understanding of the technologies and techniques that had made Jurassic World possible, ensuring that visitors would approach their dinosaur encounters with enthusiasm rather than appropriate caution. The behind-the-scenes tours that were offered to VIP guests provided access to Wu's laboratories and breeding facilities. Yet, these exclusive experiences were carefully staged to showcase technological sophistication while concealing the more disturbing aspects of genetic manipulation that had been necessary to create organisms suitable for commercial exhibition. The incubation chambers and genetic sequencing equipment that visitors observed were impressive demonstrations of scientific capability, yet they revealed nothing about the behavioral conditioning and biological modifications that had transformed authentic species into artificial constructs designed to serve human entertainment preferences. The Creation Lab, that served as the public face of Wu's genetic engineering operations, was designed to inspire awe and wonder at humanity's power over life and death, As visitors watched newly hatched dinosaurs emerge from artificial eggs that had been carefully timed to provide dramatic moments during scheduled tour periods. These birth demonstrations were presented as miraculous resurrections of extinct species, yet the creatures that emerged from Wu's incubators bore only superficial resemblance to their ancient ancestors, having been modified to exhibit behaviors and characteristics that would maximize their entertainment value while minimizing their danger to paying customers. The Gentle Giants Petting Zoo that featured juvenile Dilophosaurus, among other supposedly harmless species, represented the ultimate expression of Masrani's philosophy of transforming prehistoric predators into interactive entertainment. As creatures whose ancestors had been among the most feared hunters of the Mesozoic era were reduced to theme park attractions that children could approach without supervision or protection. The extensive behavioral conditioning that made such interactions possible required pharmaceutical interventions and psychological manipulation that fundamentally altered the creature's neural development and social behaviors. Owen Grady's involvement in these conditioning programs brought military precision to the challenge of modifying predatory instincts that millions of years of evolution had refined for maximum killing efficiency. Yet, even his expertise in animal behavior was inadequate for addressing the psychological complexities that resulted from forcing artificial creatures to suppress the very characteristics that defined their genetic heritage. The training protocols that Owen developed were successful in creating docile exhibition animals, yet they also produced psychological damage that manifested itself through depression, anxiety, and behavioral disorders that had never been documented in natural species. The feeding schedules that governed Dilophosaurus care throughout Jurassic World were designed to maintain optimal health and appearance for public exhibition, while also ensuring complete dependence upon human management systems that could be withdrawn instantly if behavioral problems developed or security concerns arose. The synthetic nutrients that Wu had developed, specifically for modified dinosaur physiology, contained chemical additives that influenced mood and aggression levels, allowing park management to adjust the emotional states of their attractions according to operational requirements and visitor safety considerations. The veterinary protocols that Dr. Zia Rodriguez and her colleagues developed for treating genetically modified organisms required techniques and medications that had never been tested upon creatures whose biology combined elements from multiple species that had never coexisted in natural environments. The medical challenges that resulted from treating hybrid organisms whose physiological systems operated according to no known precedents created learning opportunities that advanced veterinary science, while also revealing the extent to which genetic modification had created entirely new categories of biological complexity and medical liability. The behavioral enrichment programs that were implemented to maintain psychological health among captive Dilophosaurus reflected growing recognition that creatures possessing enhanced intelligence required mental stimulation that conventional zoo management techniques could not provide. Yet these programs also served to further modify natural behaviors in ways that made the animals more suitable for exhibition, while reducing their authenticity as representatives of their extinct species. The social dynamics that emerged among Dilophosaurus populations within Jurassic World's controlled environments bore no resemblance to either the pack-hunting behaviors that paleontological evidence suggested had characterized their ancient ancestors, or the modified social structures that had developed among Site B's wild populations. The artificial constraints imposed by exhibition requirements and visitor safety concerns created social pressures that produced behavioral patterns that were unique among known species. As creatures struggled to maintain relationships and hierarchies within environments that prevented the expression of natural territorial and competitive instincts, The escape prevention protocols that surrounded every Dilophosaurus enclosure represented learning from previous disasters, combined with technological advances that promised to make containment failures impossible. Yet these security measures were designed according to assumptions about creature behavior that were based upon Wu's laboratory studies, rather than observation of how artificial organisms actually responded to stress and environmental changes when their basic needs and instincts were frustrated by captive conditions. The emergency response procedures that park management had developed for potential Dilophosaurus incidents reflected both institutional memory of previous disasters and overconfidence in humanity's ability to control forces that had proven uncontrollable in every previous encounter, as detailed protocols for managing escaped creatures assumed that technological superiority and superior planning would provide decisive advantages over predatory instincts that had been enhanced rather than diminished by genetic modification. The Asset Containment Unit that Vic Hoskins had established specifically for managing dangerous dinosaur incidents represented the militarization of wildlife management in response to threats that conventional animal control techniques were inadequate to address. Yet the weapons and tactics that this specialized force had developed were based upon combat experience with human adversaries, rather than encounters with creatures whose capabilities transcended those of any natural predator. The public relations strategies that Masrani Global employed to maintain visitor confidence in dinosaur safety were carefully crafted to emphasize technological control and scientific expertise, while minimizing discussion of the inherent unpredictability that characterized all interactions with genetically modified organisms whose behavior patterns could not be predicted based on any known precedents. These marketing campaigns created public expectations about dinosaur encounters that bore no relationship to the actual risks and challenges that artificial creatures presented. Claire Deering's evolution from corporate executive to dinosaur advocate reflected growing awareness among park personnel that the creatures they managed were not merely expensive attractions, but living beings whose welfare had been compromised by the commercial considerations that governed every aspect of their existence. Her transformation from viewing dinosaurs as assets to recognizing them as individuals with rights and interests that deserved protection marked a significant shift in institutional thinking about the ethical obligations that genetic resurrection had created. The research programs that Wu continued to pursue during Jurassic World's operational period pushed the boundaries of genetic modification far beyond the relatively conservative approaches that had characterized his earlier work, as commercial pressures and competitive dynamics drove him to attempt creations that prioritized spectacular effect over biological stability or scientific authenticity. The hybrid organisms that emerged from these advanced programs represented the ultimate expression of genetic engineering as entertainment technology rather than biological science. The Indominus Rex project that would eventually consume Wu's attention and Masrani's resources was conceived during this period as the logical extension of the entertainment-focused approach to genetic resurrection that had characterized Jurassic World's entire philosophy. Yet the creature that would emerge from these experiments would prove that some applications of genetic modification created dangers that no amount of technological sophistication could predict or control. The corporate culture that developed within Jurassic World's management structure reflected both the commercial priorities that drove all decision-making processes and the persistent denial of responsibility that had characterized every institution involved in genetic resurrection since Hammond's original experiments. The systematic prioritization of profit over safety, entertainment over authenticity, and corporate interests over creature welfare created conditions that virtually guaranteed the repetition of disasters that previous experience should have taught humanity to avoid. The educational mission that Jurassic World claimed to serve was corrupted by commercial considerations that transformed scientific information into marketing content designed to promote visitor engagement rather than genuine understanding of paleontology, evolution, or the ecological relationships that had sustained prehistoric life. The simplified and dramatized presentations that visitors received created misconceptions about dinosaur biology and behavior that were more harmful than beneficial to public understanding of natural history. The international acclaim that Jurassic World received from entertainment industry professionals and tourism organizations reflected the success of Masrani's vision in creating spectacular experiences that satisfied audience expectations for thrills and excitement. Yet this acclaim came at the cost of scientific credibility and respect for the creatures whose modified genetics had made such entertainment possible. The financial success that Jurassic World achieved during its brief operational period demonstrated that public appetite for dinosaur encounters was sufficient to justify the massive investments that genetic resurrection required. Yet, this commercial triumph also encouraged further experimentation, with modifications and enhancements that pushed the boundaries of biological manipulation into territories that no previous research had explored. The legacy specimens that remained from Wu's original work with InGen provided genetic material and behavioral baselines that informed the development of new Dilophosaurus populations specifically designed for Jurassic World's entertainment requirements. Yet these authentic samples also served as reminders of what had been lost when scientific curiosity was subordinated to commercial objectives and theatrical effect was prioritized over biological accuracy. The preservation of genetic diversity among Dilophosaurus populations required careful management of breeding programs that balanced the need for sufficient numbers to sustain viable populations with the practical limitations imposed by exhibition requirements and facility capacity. Yet these conservation efforts were undermined by the very modifications that made the creatures suitable for commercial display, as genetic alterations that served entertainment purposes often compromised reproductive success and population viability. The international regulations that governed genetic engineering research during this period were systematically circumvented through jurisdictional arbitrage and corporate legal strategies that exploited gaps and ambiguities in legislative frameworks that had been developed without adequate understanding of the challenges that genetic resurrection would create. The resulting regulatory failures ensured that Masrani's operations could proceed without effective oversight or accountability for the biological and ethical consequences of their activities. The scientific community's response to Jurassic World's approach to genetic resurrection was characterized by both fascination with the technological achievements that the project represented and growing concern about the ethical implications of transforming extinct species into commercial entertainment rather than conducting serious research into paleobiology and evolutionary history. These conflicted reactions reflected broader debates about the appropriate applications of genetic engineering technologies and the responsibilities that came with the power to create and modify life itself. In the deep places where institutional memory preserved the records of humanity's ongoing struggle with the consequences of genetic resurrection, the files documenting Jurassic World's approach to Dilophosaurus management served as examples of how commercial success could be achieved through the systematic abandonment of scientific principles and ethical obligations that should have governed interactions between human institutions and the artificial creatures whose existence those institutions had made possible. In the summer of 2015, when Jurassic World stood at the height of its commercial success and visitors from around the globe came to witness miracles of genetic resurrection that previous generations could never have imagined, 6 young souls arrived upon Isla Nublar carrying with them the enthusiasm and curiosity that characterized adolescence, yet also the vulnerability that made them ideal subjects for observing how artificial creatures responded to genuine human emotion uncorrupted by adult preconceptions about corporate liability and operational efficiency. The Camp Cretaceous program that had been designed to provide intensive educational experiences for selected teenagers represented Masrani Global's attempt to cultivate the next generation of customers, while also conducting informal, behavioral studies of how young humans interacted with genetically modified organisms under conditions that approximated natural encounters, rather than the carefully choreographed exhibitions that characterize standard park operations. The selection of participants had been guided by psychological profiles that identified individuals whose personalities and backgrounds would provide diverse perspectives on dinosaur encounters, while also ensuring adequate supervision, safety margins. Darius Bowman, whose encyclopedic knowledge of dinosaur species had been accumulated through years of obsessive study, motivated by genuine fascination rather than academic requirement, arrived at camp with expectations that had been shaped by paleontological research and theoretical understanding, rather than direct observation of how Dr. Wu's modifications had transformed authentic species into artificial constructs designed to serve commercial rather than scientific purposes. His expertise in recognizing behavioral patterns and ecological relationships would prove both invaluable for survival and tragically inadequate for predicting the actions of creatures whose neural architecture had been modified according to principles that bore no relationship to natural evolution. The Dilophosaurus populations that inhabited the restricted areas surrounding the main camp facilities had been deliberately maintained at reduced densities and enhanced dependency levels that were supposed to ensure their compliance with safety protocols, while still providing educational opportunities for observing predatory behaviors under controlled conditions. These creatures represented Wu's most successful attempts at behavioral modification, having been conditioned through years of pharmaceutical intervention and environmental manipulation to display curiosity rather than aggression when encountering human beings who posed no immediate threat to their territory or resources. The initial encounters between camp participants and Dilophosaurus specimens occurred during supervised educational tours that were designed to provide thrilling yet safe experiences of observing dangerous predators at close range, as specially trained counselors used behavioral conditioning techniques and environmental controls to ensure that creature responses remained within acceptable parameters for juvenile human observers. The theatrical nature of these interactions reflected the entertainment industry background that influenced every aspect of Jurassic World's operational philosophy. Dave and Roxy, the counselors whose responsibility for protecting their young charges should have been their primary concern, had instead been transformed by corporate training programs into entertainers whose success was measured by visitor satisfaction rather than absolute safety, creating institutional pressures that encourage spectacular experiences rather than cautious management of encounters between vulnerable humans and creatures whose behavior could never be completely predicted or controlled despite years of conditioning and modification. The nocturnal expedition that violated camp safety protocols and brought the teenagers into direct contact with uncontrolled Dilophosaurus specimens revealed both the inadequacy of behavioral conditioning when creatures were confronted with unexpected stimuli, and the extent to which Wu's modifications had created internal conflicts between natural, predatory instincts and artificial behavioral programming that could be triggered by environmental changes or social pressures. The pack of Dilophosaurus that the campers encountered during their unauthorized exploration displayed behavioral characteristics that fell somewhere between the docility that their conditioning was supposed to ensure and the aggressive, hunting strategies that their genetic heritage had preserved. Despite decades of modification and pharmaceutical intervention, these creatures were neither the harmless attractions that park marketing had promised, nor the efficient killers that their ancient ancestors had been, but rather confused and conflicted organisms whose artificial nature created behavioral inconsistencies that made their responses to human presence fundamentally unpredictable. The hooting vocalizations that announced the creature's presence served both as territorial warnings and as expressions of the psychological distress that resulted from forcing predatory species to suppress their natural behavioral patterns in service of human entertainment requirements. The sounds that emerged from their modified vocal apparatus were recognizably similar to those that paleontological research suggested their ancestors had produced, yet they carried emotional undertones that reflected the trauma and confusion that characterized all of Wu's genetically modified organisms. Brooklyn's attempt to document the encounter through her recording equipment revealed how completely modern human perspectives had been shaped by digital media consumption rather than direct experience with dangerous wildlife, as her instinct to create content for social media platforms superseded survival reflexes that millions of years of evolution had programmed into human neural architecture. The footage she captured provided valuable documentation of Dilophosaurus behavior under stress conditions, yet it also demonstrated the extent to which contemporary culture had disconnected young people from realistic assessments of danger and appropriate responses to predatory threats. The rescue intervention by camp counselors demonstrated both the effectiveness of emergency protocols when properly implemented and the narrow margins by which disaster was being averted on a daily basis throughout Jurassic World's operations. As staff members who had been trained to handle routine educational activities found themselves managing life-threatening emergencies that required expertise and equipment that their standard preparation had never anticipated or provided. The disciplinary response that assigned Darius and Kenji to cleaning duties rather than educational activities reflected adult failure to understand that the teenagers' rule violations had been motivated by the same scientific curiosity that the camp program was ostensibly designed to foster, creating contradictions between stated educational objectives and actual management priorities that emphasized compliance over learning and risk avoidance over genuine engagement with natural history. The underground service tunnels that Kenji revealed during their punishment detail provided access to areas of the park that were considered too dangerous for public exhibition, including containment facilities that housed specimens whose behavioral modifications had been unsuccessful or whose psychological conditions made them unsuitable for interaction with visitors, despite millions of dollars in research and development investments that corporate accounting required to be preserved rather than terminated. The Carnotaurus designated as Toro that the boys encountered in the subsurface facilities represented one of Wu's less successful attempts at behavioral modification, as this creature had proven resistant to conditioning programs and pharmaceutical interventions that had been effective with other species, retaining levels of aggression and territorial behavior that made it unsuitable for exhibition, yet too valuable to destroy, despite the ongoing costs and risks associated with its maintenance. The confrontation between Kenji and Toro in the service cage provided both a terrifying demonstration of what unmodified predatory behavior looked like when compared to the artificially diminished creatures that populated the park's public areas, and a revelation of how quickly controlled situations could deteriorate into lethal emergencies when technological safeguards failed or human judgment proved inadequate for managing encounters with apex predators whose capabilities exceeded those of any modern wildlife. The scar that Kenji inflicted upon Toro during his escape created a permanent reminder of human resistance that would influence the creature's future behavior and establish a personal vendetta that transcended the general territorial instincts that normally governed predator-prey relationships, demonstrating how individual experiences could override genetic programming and create unique behavioral patterns that no amount of theoretical preparation could predict or address. The discovery of Dr. Wu's private office during the educational tour provided Brooklyn with access to classified information that revealed the extent to which public presentations about genetic resurrection had been sanitized and simplified to conceal the Brooklyn, more disturbing aspects of creating organisms specifically designed to serve commercial rather than scientific purposes, while also exposing the development of hybrid projects that pushed the boundaries of genetic modification far beyond anything that previous research had attempted. The blueprints for the Indominus Rex that Brooklyn discovered represented the ultimate expression of Wu's evolution from scientist to entertainment designer, as this projected hybrid would combine genetic material from multiple species to create a creature that existed solely to provide thrills for park visitors, rather than advance understanding of paleobiology or evolutionary history. The documents revealed that authenticity had been completely abandoned in favor of spectacular effect, while safety considerations had been subordinated to commercial objectives that prioritized visitor excitement over operational prudence. Sammy's simultaneous investigation of Wu's facilities, conducted under cover of seeking restroom facilities, reflected the industrial espionage mission that she had been unknowingly recruited to perform on behalf of Manticorp, as her youth and apparent innocence provided perfect cover for collecting genetic samples and technical documentation that would eventually enable competing corporations to establish their own dinosaur research programs without the massive investments in original development that InGen's work had required. The birth of the Ankylosaurus that the campers witnessed represented both the miracle of genetic resurrection and the tragedy of artificial creation, as a creature that had been extinct for millions of years drew its first breath in a world that bore no resemblance to its ancestral habitat yet, was forced to adapt to conditions that had been designed according to human aesthetic preferences rather than biological requirements that its evolution had established through millions of years of environmental pressure. Ben's emotional connection to the newly hatched Bumpy reflected the natural human tendency to form attachments to vulnerable creatures regardless of their species or origins. Yet this bond also represented the kind of interspecies relationship that Wu's behavioral modifications were specifically designed to encourage, as creatures that formed emotional connections with human caretakers were more likely to display the docile and interactive behaviors that theme park operations required. The asymmetrical growth pattern that characterized Bumpy's development reflected the genetic instabilities that affected many of Wu's cloning successes, as the artificial reconstruction of ancient genomes often produced organisms whose development deviated from normal patterns in ways that were not necessarily harmful to the creatures themselves, but served as constant reminders that these were not authentic resurrections of extinct species, but rather artificial constructs whose biology had been modified according to human preferences and technical limitations. The drone surveillance that monitored Sammy's sample collection activities represented Manticorp's sophisticated intelligence operation, which had been conducting covert observation of InGen's facilities for years in preparation for corporate espionage campaigns that would eventually provide competitors with access to proprietary genetic technologies without the proprietary genetic technologies, massive research and development costs. That original innovation required the ability to maintain undetected surveillance within Jurassic World's supposedly secure facilities demonstrated how vulnerable even the most advanced installations were to infiltration by adversaries who possessed sufficient resources and determination. The emotional trauma that Ben experienced following his apparent abandonment by the evacuation procedures reflected both the psychological impact of finding himself alone in an environment populated by dangerous predators and the gradual realization that adult authority figures who had promised to protect him had proven inadequate for managing crises that exceeded their training and preparation. His transformation from anxious rule follower to capable survivor would require fundamental changes in personality, an outlook that challenged every assumption about human adaptability and resilience. The relationship that developed between Ben and Bumpy during their shared isolation demonstrated that authentic emotional bonds could indeed form between species, despite the artificial nature of the dinosaurs' genetic heritage. As the young Ankylosaurus responded to human companionship in ways that transcended the behavioral conditioning that was supposed to govern all creature interactions with park personnel, their mutual dependence created a survival partnership that was based upon genuine affection, rather than the manipulative relationships that characterized most human dinosaur interactions within Jurassic World's operational framework. The survival skills that Ben developed during his weeks alone on the island represented both successful adaptation to hostile conditions and psychological transformation that separated him from the sheltered existence that had characterized his previous life, as he learned to read environmental signs, avoid predatory threats, and exploit the abandoned infrastructure that remained from the park's operational period. His evolution from frightened child to competent wilderness survivor demonstrated human potential for growth under extreme pressure. The other campers' discovery that they had been abandoned during the general evacuation created both immediate survival challenges and longer-term psychological pressures that would test their individual capabilities and collective cohesion in ways that their comfortable suburban backgrounds had never prepared them to handle, as they were forced to confront realities about institutional priorities that placed corporate liability concerns above individual human welfare, particularly when those individuals were minors whose legal guardianship had been temporarily transferred to corporate entities. The base camp that the survivors established in the ruins of the original Camp Cretaceous facilities provided both practical shelter and psychological comfort as they worked together to create routines and maintain morale under conditions that challenged every assumption about adult protection and institutional reliability that had previously defined their understanding of social relationships and organizational behavior. The Dilophosaurus encounters that occurred during their extended survival period revealed how creatures that had been conditioned for controlled exhibition environments responded to the breakdown of human management systems, as the absence of regular feeding schedules, pharmaceutical interventions, and behavioral conditioning created stress conditions that triggered responses which their artificial programming had been designed to suppress, but could not permanently eliminate. The pack dynamics that emerged among the island's abandoned Dilophosaurus populations reflected both their genetic heritage as social predators and the artificial modifications that had been introduced to make them suitable for theme park exhibition, creating behavioral patterns that were neither fully natural nor completely artificial, but rather represented hybrid responses to environmental conditions that had never existed during their species' original evolutionary development. The problem-solving capabilities that the creatures displayed when confronted with novel challenges demonstrated that Wu's modifications had preserved and perhaps enhanced the cognitive abilities that had made their ancient ancestors successful predators, while the artificial nature of their neural architecture created approaches to environmental obstacles that were simultaneously more creative and less efficient than natural evolutionary solutions would have produced. The scavenging behaviors that the Dilophosaurus adopted during the park's operational breakdown reflected both their reduced size and modified aggression levels, as creatures that should have been apex predators were forced to exploit food sources that their ancestors would never have considered, creating ecological relationships that had no precedent in natural history and could not be predicted based on paleontological evidence or theoretical modeling. The territorial disputes that erupted among different Dilophosaurus groups revealed how the artificial constraints of theme park management had suppressed natural competitive behaviors that reasserted themselves once human control systems failed. Yet these conflicts were also modified by the behavioral conditioning and genetic alterations that had been introduced to make the creatures suitable for exhibition, creating violence that was neither purely instinctual nor completely artificial. The campers' growing understanding of Dilophosaurus behavior through direct observation rather than theoretical study provided them with survival advantages that formal education could never have supplied, as they learned to read the creatures' vocalizations, interpret their body language, and predict their responses to environmental changes in ways that enabled successful coexistence, despite the absence of technological barriers or adult supervision. The psychological adaptation that each camper underwent during their extended survival experience reflected both individual personality characteristics and the collective dynamics that developed among the group as they learned to balance personal needs with community requirements, while adapting to conditions that challenged every assumption about safety, security, and institutional protection that had previously defined their expectations about adult responsibility and social organization. The evidence of larger Dilophosaurus specimens in areas that had been closed to public access provided disturbing confirmation that Wu's size reduction modifications had not been as comprehensive as official documentation suggested, as some creatures had apparently overcome the genetic constraints that were supposed to ensure permanent dependence upon human management, while also limiting their growth to dimensions suitable for controlled exhibition. The discovery of abandoned research facilities that contained references to classified genetic modification programs revealed that the creatures the campers had been observing represented only a small fraction of the experimental organisms that InGen had created, while many more dangerous and unpredictable specimens remained in containment areas that were designed to prevent both escape and public awareness of their existence. In the deep places where institutional memory preserved the records of corporate genetic engineering programs that had exceeded their original parameters and produced organisms whose capabilities transcended their creators' ability to predict or control, the experiences of the Camp Cretaceous survivors served as documentation of how artificial creatures responded to environmental conditions that their programming had never anticipated, and how young humans adapted to challenges that modern civilization had assumed would never need to be faced by individuals who lacked specialized training and adult supervision. In the year 2018, when the world had grown accustomed to sharing its ecosystems with creatures from geological epochs that predated human civilization by millions of years, The Dilophosaurus populations that had dispersed across global habitats following the collapse of corporate containment systems began to establish themselves in ecological niches that bore no resemblance to either their ancient territories or the artificial environments that genetic engineering had originally designed them to inhabit. The integration of these modified predators into modern food webs created cascading effects that challenged every assumption about conservation biology, wildlife management, and the long-term consequences of introducing artificially resurrected species into ecosystems that had evolved without any consideration of their potential presence. The behavioral adaptations that emerged among wild Dilophosaurus populations during their first years of freedom revealed both the resilience of life in overcoming artificial constraints and the profound ways in which Dr. Wu's genetic modifications had permanently altered the fundamental characteristics that had defined their species during its original evolutionary history. These creatures possessed neither the authentic predatory capabilities of their ancient ancestors, nor the controlled docility that had characterized their captive existence, but rather displayed hybrid behavioral patterns that were uniquely adapted to survival in environments that combined modern ecological conditions with the persistent influence of genetic programming that had been designed to serve human entertainment rather than natural selection pressures. The urban environments that some Dilophosaurus groups had colonized provided unexpected opportunities for creatures whose artificial intelligence had been enhanced beyond natural parameters, while their physical capabilities had been deliberately constrained by corporate safety requirements, creating predators that were ideally suited for exploiting the complex three-dimensional landscapes and abundant food sources that characterized modern cities. The behavioral flexibility that Wu's modifications had introduced into their neural architecture allowed them to adapt to concrete and steel environments with remarkable success, while their reduced size made them capable of occupying ecological niches that larger predators could never have exploited. Owen Grady's controversial involvement in Dilophosaurus management programs reflected both his unique expertise in dinosaur behavior and the institutional recognition that conventional wildlife control techniques were inadequate for Rudian managing creatures whose characteristics transcended every category that existing regulatory frameworks had been designed to address. His methods, developed through years of working with velociraptors, whose intelligence and capabilities exceeded those of any modern predator, were adapted for creatures whose artificial modifications created behavioral challenges that were simultaneously more complex and more manageable than those posed by their unmodified relatives. The physical restraint techniques that Owen demonstrated during his public encounters with escaped Dilophosaurus specimens were based upon understanding of their modified neural architecture and the behavioral conditioning that had been imposed during their development within controlled environments. Yet, his apparent ability to subdue dangerous predators through manual force was actually dependent upon pharmaceutical interventions and electronic control systems that remained invisible to observers who witnessed only the dramatic conclusion of carefully orchestrated capture operations. The public relations value of Owen's demonstrations far exceeded their practical utility for wildlife management, as his theatrical displays of human dominance over prehistoric predators served to reassure civilian populations that governmental authorities possessed the expertise and capability necessary to manage any threats that escaped dinosaurs might pose to human communities. Yet these carefully staged performances also created dangerous misconceptions about the actual risks and challenges associated with Dilophosaurus encounters, leading to complacency and inadequate preparation among emergency response personnel and civilian populations. The tracking technologies that governmental agencies deployed to monitor Dilophosaurus movements through populated areas represented unprecedented attempts to maintain surveillance over wild animal populations, whose behavior patterns could not be predicted based upon any existing models of predator, ecology, or territorial organization. The electronic tags and GPS monitoring devices that were surgically implanted in captured specimens provided continuous data streams about creature locations and activities. Yet, the information gathered through these systems often contradicted theoretical predictions about how artificially modified organisms would respond to environmental challenges and social pressures. The territorial boundaries that wild Dilophosaurus established in urban and suburban environments reflected both their reduced aggression levels and their enhanced intelligence, as they learned to exploit human infrastructure and behavioral patterns to secure resources while avoiding confrontations that their modified physiology was not equipped to handle successfully. These territories were smaller and more precisely defined than paleontological evidence suggested their ancestors had claimed, yet they were also more complex in their internal organization and more efficiently defended through behavioral strategies rather than physical violence. The dietary adaptations that characterized urban Dilophosaurus populations demonstrated remarkable flexibility in exploiting food sources that bore no resemblance to the prey species that had sustained their ancient ancestors or the specially formulated nutrients that had been provided during their captive development. The scavenging behaviors that became their primary feeding strategy were supplemented by opportunistic hunting of small mammals and birds, while their artificial venom delivery systems proved effective for subduing prey that their reduced size and strength would not normally have allowed them to capture. The pack dynamics that emerged among urban Dilophosaurus groups bore no resemblance to either the coordinated hunting strategies that fossil evidence suggested had characterized their species' original social organization, or the pack simplified behavioral patterns that Wu's conditioning programs had imposed during their laboratory development. These new social structures were organized around resource sharing and territorial defense rather than predatory cooperation, reflecting both their modified neural architecture and the environmental constraints that urban living imposed upon creatures whose evolutionary heritage had been shaped by entirely different ecological pressures. The public health challenges that resulted from establishing Dilophosaurus populations in areas with dense human settlement included both direct risks from predatory encounters and indirect consequences of introducing artificial organisms whose waste products and metabolic byproducts had never been evaluated for their environmental impact or potential toxicity to native species and human populations. The synthetic biochemical compounds that characterized their bodily functions created pollution signatures that existing environmental monitoring systems were not designed to detect or assess. The veterinary medicine that was required for treating Dilophosaurus injuries and diseases in wild populations represented entirely new specializations that combined traditional wildlife management techniques with understanding of artificial biological systems that operated according to no known natural precedents. The hybrid nature of their physiology meant that conventional medications and treatment protocols often produced unpredictable results, while their modified immune systems created vulnerabilities to pathogens that would never have affected their ancient ancestors. The illegal wildlife trade that developed around captured Dilophosaurus specimens reflected both their status as unique biological curiosities and the enormous financial incentives that drove criminal organizations to exploit the demand for exotic animals among collectors who viewed resurrected species as ultimate status symbols. The black market prices that these creatures commanded exceeded those of any natural wildlife, while their artificial modifications made them particularly valuable for research institutions and private collectors who sought access to genetic technologies that were officially restricted or prohibited. The breeding programs that emerged within captive populations held by private collectors and research institutions operated without regulatory oversight or scientific protocols, creating opportunities for genetic experimentation that exceeded anything that official institutions had attempted, while also introducing risks of uncontrolled mutation and hybrid development that could potentially create organisms whose capabilities and characteristics transcended even those that Dr. Wu's original research had achieved. Lewis Dodgson's final encounter with Dilophosaurus specimens during the Biocene crisis represented both the culmination of decades of corporate espionage focused on acquiring proprietary genetic technologies and the ultimate failure of attempts to control or exploit creatures whose artificial nature made them fundamentally incompatible with human institutional systems and commercial objectives. The deleted scenes that documented his original death scenario revealed corporate recognition that authentic encounters with unmodified specimens would have produced outcomes too disturbing for public consumption. The alternative death sequence that had been planned for Dodgson involved initial confrontation with smaller, modified Dilophosaurus specimens that displayed the familiar behavioral patterns and reduced threat levels that audiences had learned to associate with the species, followed by revelation of larger, less modified individuals whose capabilities more closely approximated those of their ancient ancestors. This escalating threat structure was designed to demonstrate both the evolution of genetic modification techniques and the persistent dangers that resulted from corporate attempts to improve upon natural evolutionary designs. The systematic concealment of authentic adult Dilophosaurus specimens from public awareness reflected institutional recognition that full disclosure of Wu's research achievements would have created regulatory responses and public opposition that could have threatened the entire genetic resurrection industry. While the existence of creatures whose capabilities exceeded official acknowledgements provided corporate entities with strategic advantages that were considered too valuable to sacrifice for transparency or public safety considerations. The size variations that were documented among global Dilophosaurus populations provided evidence that environmental conditions and genetic expression patterns were interacting in ways that allowed some individuals to overcome the growth limitations that had been engineered into their developmental programming, while others remained constrained by the artificial restrictions that Wu's modifications had imposed. These variations suggested that genetic modification was not the permanent and controllable process that corporate marketing had claimed. The behavioral studies that were conducted during this period revealed that while Dilophosaurus possessed problem-solving capabilities and environmental awareness that exceeded those of their captive-bred relatives by significant margins, as exposure to genuine survival challenges had triggered genetic expression patterns and neural development pathways that controlled conditions had never activated. The enhanced intelligence that resulted from these adaptations created creatures that were simultaneously more capable and more unpredictable than their laboratory-raised predecessors. The military applications research that Vic Hoskins had initiated during his tenure with InGen continued under different institutional auspices, as governmental agencies and private military contractors recognized that Dilophosaurus intelligence and capabilities could potentially be weaponized for applications that conventional military assets could not address. The psychological warfare potential of creatures that combined prehistoric appearance with artificial enhancement made them attractive options for asymmetric conflict scenarios where conventional deterrence was inadequate. The training protocols that were developed for potential military applications of Dilophosaurus capabilities required techniques that combined traditional animal conditioning with understanding of artificial neural architecture and the behavioral modifications that genetic engineering had introduced into their cognitive development. The results of these experiments remained classified, yet their existence suggested that the weaponization of resurrected species was being pursued despite official policies that prohibited such applications. The ecological monitoring programs that tracked the environmental impact of establishing Dilophosaurus populations in regions where they had never existed revealed complex cascading effects that extended throughout entire food webs, as their presence altered predator-prey relationships, competitive dynamics, and resource distribution patterns in ways that created both benefits and problems for native species that had evolved without any consideration of their potential interactions with artificially modified organisms. The conservation paradoxes that resulted from protecting Dilophosaurus populations while simultaneously managing their impact upon threatened native species created unprecedented challenges for wildlife management agencies whose existing protocols and legal frameworks were inadequate for addressing conflicts between conservation obligations and practical necessity. The hybrid nature of these creatures made them simultaneously endangered species, deserving of protection, and invasive organisms, requiring control or elimination. The international agreements that were negotiated to coordinate management of transnational Dilophosaurus populations reflected both the global scope of the challenges that genetic resurrection had created and the inadequacy of existing institutional mechanisms for addressing problems that transcended traditional boundaries between nations, species, and natural versus artificial categories of biological organization. The scientific research that was conducted using wild Dilophosaurus populations provided unprecedented opportunities to study evolutionary adaptation in real time, as these creatures represented the first artificially created organisms that had been subjected to genuine natural selection pressures over extended periods under diverse environmental conditions. The data gathered from these studies advanced understanding of both evolution and genetic engineering, while also revealing the extent to which Wu's modifications had created organisms whose biological characteristics were fundamentally different from those of any naturally evolved species. The philosophical debates that emerged within scientific and ethical communities during this period focused upon questions about the moral status of artificially created organisms and the extent to which human institutions had obligations to protect or control creatures whose existence resulted from technological intervention rather than natural evolutionary processes. These discussions revealed fundamental disagreements about the nature of life itself and the responsibilities that came with the power to create and modify living beings according to human preferences and objectives. The public education campaigns that were implemented to inform civilian populations about appropriate responses to Dilophosaurus encounters reflected both governmental recognition that coexistence with resurrected species was inevitable and acknowledgement that existing knowledge about wildlife safety was inadequate for addressing threats posed by creatures whose capabilities and behavioral patterns fell outside the parameters of natural predator ecology. The insurance and liability frameworks that evolved to address Dilophosaurus-related incidents represented unprecedented attempts to quantify and distribute financial responsibility for damages caused by artificially created organisms, whose behavior could not be predicted based upon any established precedents. While the legal principles that emerged from these cases established new categories of environmental law and corporate accountability that would influence regulation of genetic engineering for decades to come, the cultural impact of integrating Dilophosaurus populations into human-dominated landscapes extended far beyond immediate practical considerations of safety and wildlife management, as these creatures became symbols of humanity's relationship with technology, nature, and the consequences of attempts to control forces that operated according to principles that transcended human understanding or institutional authority. In the deep places where societal memory preserved the records of humanity's ongoing struggle to coexist with forces that their own technologies had unleashed but could not control, the documentation of global Dilophosaurus integration served as evidence both of species resilience in overcoming artificial constraints and of institutional failure to acknowledge the full scope of responsibility that came with the power to resurrect and modify life itself according to preferences that prioritized human interests over biological authenticity and ecological stability. In the shadow archives where corporate secrecy had concealed the most profound truths about genetic resurrection from public scrutiny and scientific accountability, there lay buried beneath layers of classification and deliberate obfuscation the evidence that would transform humanity's understanding of what had truly been achieved in the sterile laboratories where life and death had become subjects for technological manipulation rather than natural processes governed by principles that transcended human comprehension or control. The revelations that began to surface in the years following Jurassic World's collapse would challenge every assumption about the scope and intentions of genetic engineering programs that had operated beyond the boundaries of ethical oversight or democratic accountability. Stan Winston, the visionary, whose practical effects wizardry had brought the first Dilophosaurus to life in ways that audiences would never forget, had preserved within his personal archives documentation that revealed the extent to which commercial considerations had corrupted the scientific accuracy that should have guided every aspect of dinosaur recreation for public consumption. His private notes from the original Jurassic Park production contained explicit statements that the Dilophosaurus specimens featured in the film were intended to represent juvenile individuals rather than fully mature adults. Yet this crucial distinction had been systematically omitted from all subsequent discussions about the creature's authentic size and capabilities. The concept art and technical specifications that Winston's team had developed during their preparation for bringing prehistoric creatures to cinematic life included detailed illustrations of adult Dilophosaurus that bore little resemblance to the relatively modest specimens that had ultimately appeared on screen, as budgetary constraints and narrative requirements had forced the production team to scale down their ambitions in ways that created lasting misconceptions about the true dimensions that characterized this distinctive predator during its original evolutionary reign. The paleontological consultants, who had provided scientific guidance for the original film's creature designs, had expressed concerns about the artistic liberties that were being taken with Dilophosaurus anatomy and behavior. Yet their objections had been overruled by entertainment industry professionals who prioritized dramatic effect over educational accuracy, establishing precedents that would influence every subsequent depiction of resurrected species in ways that made authentic scientific understanding increasingly difficult to achieve or maintain. The merchandising requirements that governed character design decisions during the film's development had explicitly favored creatures that could be easily reproduced as toys and collectibles over those that accurately represented paleontological evidence about prehistoric anatomy and behavior, creating commercial incentives that systematically distorted public understanding of what genetic resurrection might actually achieve if it were pursued according to scientific rather than entertainment industry principles. InGen's internal corporate documents, preserved within classified archives that would not become accessible to researchers until decades after the original Jurassic Park incident, contained detailed technical specifications for Dilophosaurus, genetic reconstruction that revealed the extent to which Dr. Wu's modifications had been driven by practical considerations rather than scientific curiosity about authentic prehistoric biology. The engineering reports that documented his decision-making process showed that creature size reduction had been implemented, not as an unintended consequence of genetic limitations, but as a deliberate corporate strategy designed to minimize operational costs and liability risks. The cost-benefit analyses that had guided Wu's approach to genetic modification revealed that maintaining full-sized Dilophosaurus specimens would have required facility construction and maintenance expenses that exceeded InGen's budget projections by margins that made authentic recreation financially impossible, given the commercial timeline that corporate leadership had established for park development. The decision to create reduced-scale versions of prehistoric species had been presented to investors as temporary compromise that would be addressed through future research. Yet, internal memos made clear that permanent size reduction was always intended as the final outcome. The comparative studies that Wu's team had conducted between authentic paleontological dimensions and the scaled-down creatures that emerged from their laboratories documented size discrepancies that exceeded 50% in many cases. Yet these deviations were consistently described in official reports as minor adjustments necessary for accommodation within existing infrastructure, rather than fundamental alterations that transformed one species into something entirely different. The elephant analogy that John Hammond had employed when explaining his vision for Jurassic Park to potential investors was not merely a rhetorical device, but rather reflected actual corporate policies that had been implemented to ensure that all resurrected species would be reduced to dimensions that could be managed through conventional zookeeping techniques, rather than the specialized protocols that authentic prehistoric predators would have required. The scaling algorithms that Wu had developed for modifying genetic growth factors were applied not only to Dilophosaurus, but to virtually every species that InGen had attempted to resurrect, creating systematic distortions that affected entire ecosystems of artificial creatures whose interactions bore no resemblance to the ecological relationships that had characterized authentic Mesozoic environments. The tissue samples and genetic materials that had been preserved from Wu's original research provided evidence that complete genomic sequences for full-sized Dilophosaurus had indeed been successfully reconstructed during the preserved early phases of InGen's development program. Yet corporate decisions about facility design and operational requirements had prevented these authentic genetic templates from ever being expressed through actual organism development. The cryogenic storage facilities that housed unused genetic materials included viable samples that could theoretically have been employed to create Dilophosaurus specimens whose dimensions matched paleontological evidence. Yet access to these materials had been restricted by corporate security protocols that classified authentic genetic sequences as proprietary information too valuable to risk through experimental applications that might result in specimen loss or competitive intelligence gathering by rival organizations. The bioethical review panels that had been established to provide oversight for InGen's genetic reconstruction programs had raised questions about the appropriateness of systematically reducing creature sizes for commercial convenience. Yet, their recommendations had been ignored or overruled by corporate leadership, who viewed such modifications as necessary accommodations rather than fundamental violations of scientific integrity or species authenticity. The environmental impact assessments that documented the ecological consequences of introducing artificially reduced predators into island ecosystems revealed cascading effects that extended throughout entire food webs, as creatures whose size had been modified for human convenience could no longer fulfill the ecological roles that their genetic heritage had programmed them to occupy within natural community structures. The behavioral conditioning protocols that had been developed to compensate for the psychological trauma that resulted from forcing predatory species to accept artificial size limitations included pharmaceutical interventions and neural team modification techniques that went far beyond anything that conventional animal training had ever attempted, creating dependencies and behavioral abnormalities that transformed authentic species into artificial constructs that bore only superficial resemblance to their evolutionary templates. The research partnerships that InGen had established with academic institutions included contractual provisions that prohibited participating scientists from discussing the full scope of genetic modifications that were being implemented, ensuring that peer review and scientific publication would never reveal the extent to which commercial considerations had corrupted genetic resurrection projects that were ostensibly conducted for educational and scientific purposes. The classified military contracts that had provided funding for advanced genetic engineering research included specifications for creatures whose capabilities would be optimized for combat applications rather than scientific accuracy or educational value, creating incentives for developing organisms whose characteristics prioritize tactical effectiveness over biological authenticity or ecological viability. The deleted footage from various Jurassic Park productions contained scenes that depicted larger Dilophosaurus specimens whose behavior and capabilities more closely approximated paleontological evidence. Yet these sequences had been removed from final releases due to ratings, concerns, and marketing department objections that authentic predatory behavior would be inappropriate for target audiences. Lewis Dodgson's alternative death scene, which had been scripted and partially filmed before being replaced with the sanitized version that appeared in the final cut, would have provided audiences with their first glimpse of what unmodified Dilophosaurus capabilities actually looked like when applied under genuine predatory conditions, rather than the controlled demonstration scenarios that characterized most dinosaur encounters in the franchise. The scene progression that had been planned would have begun with Dodgson's confident dismissal of smaller, modified Dilophosaurus specimens, whose familiar appearance and behavioral patterns would have reassured audiences that they understood the level of threat that such creatures represented, followed by the shocking revelation that these familiar animals were merely juveniles or artificially reduced versions of predators whose authentic dimensions and capabilities exceeded anything that previous films had portrayed. The practical effects and animatronic requirements for depicting full-sized adult Dilophosaurus had proven technically feasible during pre-production testing, yet the costs associated with creating and operating such sophisticated machinery had been deemed excessive, given the brief screen time that the sequence would have occupied, leading to creative decisions that prioritized budgetary efficiency over scientific education or dramatic impact. The audience testing that had been conducted using preliminary versions of the authentic Dilophosaurus encounter had produced physiological stress responses that exceeded studio guidelines for family-friendly entertainment, as viewers who had been conditioned to expect manageable threats from familiar creatures were psychologically unprepared for encounters with predators whose capabilities matched their evolutionary heritage rather than corporate modification. The insurance liability assessments that had been conducted for various production scenarios had identified significant financial risks associated with depicting creatures whose authentic capabilities might encourage dangerous wildlife. Encounters among audience members who failed to distinguish between fictional portrayals and real-world animal behavior, leading to corporate decisions that prioritized legal protection over educational accuracy. The international distribution requirements that governed content standards for global film releases had included restrictions on violence and realistic predatory behavior that made authentic Dilophosaurus encounters unsuitable for markets, where such content would have been subject to censorship or classification that would have reduced commercial viability. The franchise development strategies that had been implemented during the early stages of Jurassic Park's commercial expansion had explicitly prioritized consistency and brand recognition over scientific accuracy or educational value, creating institutional pressures that discouraged authentic species depiction in favor of familiar character designs that could be easily merchandised and replicated across multiple media platforms. The genetic database that Dr. Wu had maintained throughout his career included complete genomic sequences for authentic Dilophosaurus that had never been expressed through actual organism development, as corporate policies had required all practical applications to incorporate the size reduction modifications that made creatures suitable for commercial exhibition rather than scientific study. The research proposals that Wu had submitted for projects involving authentic-sized Dilophosaurus reconstruction had been consistently rejected by corporate oversight committees, who viewed such experiments as unnecessary risks that offered no commercial benefits sufficient to justify the additional costs and security requirements that full-scale predators would have demanded. The facility design specifications that had been developed for housing unmodified Dilophosaurus specimens included containment systems and safety protocols that exceeded anything that had been implemented for existing park operations, as authentic predators would have required security measures comparable to those employed for military weapons rather than conventional animal exhibits. The staff training programs that would have been necessary for managing full-sized Dilophosaurus populations had never been developed, as corporate leadership had determined that the specialized expertise required for handling authentic prehistoric predators would be too expensive and time-intensive to implement, given the commercial timelines that governed park development schedules. The visitor safety assessments that had been conducted for hypothetical encounters with unmodified Dilophosaurus had concluded that no existing theme park infrastructure would be adequate for protecting civilian populations from creatures whose hunting capabilities had been optimized by millions of years of evolutionary development rather than modified for human convenience and entertainment preferences. The evolutionary biology research that had been conducted using Wu's genetic databases revealed that Dilophosaurus specimens approaching their authentic paleontological dimensions would have possessed cognitive capabilities and problem-solving abilities that exceeded those of any modern predator, creating management challenges that would have required entirely new approaches to animal behavior modification and environmental control. The pack hunting simulations that had been developed using computer models based on authentic Dilophosaurus genetics had produced scenarios that demonstrated coordination and tactical sophistication that would have made containment virtually impossible using conventional zookeeping techniques, leading to corporate decisions that genetic modification was necessary for any practical application of resurrection technology. The comparative analyses that had been conducted between modified and theoretical authentic Dilophosaurus specimens revealed that size reduction had eliminated not only physical capabilities, but also social behaviors and cognitive functions that had been integral to the species' evolutionary success, transforming apex predators into diminished shadows of their ancestral heritage. The preservation protocols that had been established for maintaining viable genetic samples included provisions for potential future development of authentic specimens, once technological advances and corporate priorities made such projects feasible, yet access to these materials remained restricted by classification systems that treated complete genetic information as national security assets rather than scientific resources. The international agreements that govern genetic engineering research had included specific provisions prohibiting the development of organisms whose capabilities exceeded certain threat thresholds, creating legal barriers that prevented authentic Dilophosaurus resurrection, even when technological capabilities made such projects theoretically possible. In the deep places where corporate secrecy had buried the evidence of humanity's greatest achievements in genetic engineering, alongside documentation of the compromises and limitations that had prevented those achievements from reaching their full potential, the preserved records of what might have been accomplished served as monuments to both scientific capability and institutional failure, reminding future generations that the power to resurrect life carried with it obligations to preserve authenticity and respect the evolutionary heritage that millions of years of natural selection had created through processes that transcended human understanding or technological replication. In the dawning years of the 2020s, when humanity stood upon the threshold of possibilities that previous generations could never have imagined, yet carried within their collective memory the hard-won lessons of disasters that hubris and technological overconfidence had repeatedly inflicted upon those who believed themselves capable of controlling forces that operated according to principles older and more fundamental than human civilization itself, the prospect of witnessing authentic Dilophosaurus in all their terrible magnificence began to emerge from the realm of theoretical possibility into the domain of practical inevitability, driven by the same inexorable forces that had originally brought these creatures back from extinction's embrace. The Rebirth Project, that represented Hollywood's latest attempt to capture the wonder and terror of genetic resurrection, carried within its development the seeds of both redemption and catastrophe. As filmmakers whose understanding had been shaped by decades of sanitized portrayals grappled with the challenge of presenting audiences with creatures whose authentic capabilities would challenge every assumption about the relationship between entertainment and reality, spectacle and truth, corporate sanitization, and natural magnificence that previous productions had carefully constructed through artistic compromise and commercial calculation. The marketing materials that began to surface during the project's pre-production phase contained hints and suggestions that suggested a fundamental departure from the established approach to Dilophosaurus portrayal, as concept art and promotional imagery featured creatures whose proportions and behavioral characteristics bore closer resemblance to paleontological evidence than to the familiar, diminished versions that had populated previous installments in the franchise's ongoing exploration of humanity's complicated relationship with resurrected prehistory. The screenplay development process that guided Rebirth's narrative structure included extensive consultation with paleontologists and behavioral specialists whose expertise had been systematically excluded from earlier productions, creating opportunities for scientific accuracy to influence creative decisions in ways that commercial considerations had previously prevented, while also establishing precedents for authentic creature portrayal that could potentially transform audience expectations about what genetic resurrection entertainment should aspire to achieve. The practical effects and digital animation technologies that had been assembled for bringing these enhanced creatures to cinematic life represented unprecedented investments in realism and biological accuracy, as production teams recognized that modern audiences possessed sufficient scientific literacy to detect and reject the simplified creature designs that had satisfied earlier generations of filmgoers whose paleontological knowledge had been limited by educational systems that emphasized memorization over critical thinking. The ratings considerations that had previously constrained authentic predatory behavior depictions were being reconsidered in light of evolving cultural attitudes toward violence and realism in entertainment media, as the PG-13 classification system that had originally been designed to protect juvenile audiences from inappropriate content was adapted to accommodate the educational value that authentic dinosaur encounters could provide when presented within appropriate contextual frameworks that emphasize scientific learning over gratuitous spectacle. The precedent established by the Lost World's Eddie Carr death sequence demonstrated that audiences were capable of processing and appreciating realistic consequences of encounters with prehistoric predators when such scenes were constructed to serve narrative and thematic purposes rather than mere shock value, creating artistic justifications for depicting the full scope of capabilities that genetic resurrection had made possible through decades of technological refinement and biological understanding. The new island settings that were being developed for Rebirth's narrative provided opportunities to explore environments where corporate modification and commercial sanitization had not yet corrupted the authentic expression of resurrected species' evolutionary heritage, as locations that had remained isolated from human management systems could theoretically have preserved conditions that allowed natural selection and environmental pressure to overcome the artificial constraints that had been imposed upon earlier generations of genetically reconstructed organisms. The creative decisions that guided creature behavior design for these sequences reflected both respect for paleontological evidence and recognition that entertainment value could be enhanced rather than diminished by authentic predatory capabilities. As audiences whose expectations had been shaped by nature, documentaries, and scientific education possessed sophisticated understanding of ecological relationships that made realistic creature interactions more engaging than the simplified predator-prey dynamics that had characterized earlier productions. The adult Dilophosaurus that began to appear in concept artwork and technical specifications approached the 20-foot dimensions that Stan Winston had originally envisioned before commercial and practical constraints had forced size reduction, representing not merely larger versions of familiar creatures but fundamentally different organisms whose capabilities and behavioral patterns would challenge every assumption that audiences had developed about these distinctive predators through years of exposure to their diminished cinematic representatives. The pack hunting sequences that were being developed for these enhanced creatures drew upon recent paleontological research that had revealed sophisticated coordination and tactical planning capabilities among theropod predators, creating opportunities for depicting group behaviors that had never been accurately portrayed in previous productions due to the simplified social dynamics that resulted from genetic modification and behavioral conditioning imposed upon captive populations. The environmental storytelling opportunities that authentic-sized Dilophosaurus provided would allow filmmakers to explore themes about natural magnificence versus corporate manipulation that had been implicit in earlier productions, yet never directly addressed due to commercial considerations that prioritized entertainment value over philosophical depth or scientific education about the consequences of genetic engineering and species modification for commercial purposes. The sound design and vocal capabilities that would characterize these enhanced creatures were being developed through collaboration with acoustic specialists and animal behavior researchers, whose expertise had revealed that the complex vocalizations documented in fossil evidence suggested communication systems that exceeded the simplified calls that had been featured in previous films, creating opportunities for depicting intelligent coordination and emotional expression that would fundamentally transform audience understanding of dinosaur cognition and social complexity. The international distribution strategies that were being developed for Rebirth included provisions for educational supplementation and scientific context that would help audiences understand the distinctions between authentic paleobiological recreation and the commercial modifications that had characterized earlier genetic resurrection projects, creating frameworks for public engagement with scientific concepts that entertainment media had previously oversimplified or misrepresented through artistic license and commercial calculation. The merchandise and licensing opportunities that authentic Dilophosaurus would create were being evaluated according to criteria that balanced commercial potential with educational responsibility, as toy manufacturers and collectible producers recognized that products based upon scientifically accurate creature designs could provide learning opportunities that enhanced rather than contradicted the educational value that entertainment media was capable of delivering when commercial considerations were properly balanced with scientific authenticity. The fan community responses to early concept releases revealed both enthusiasm for authentic creature portrayal and anxiety about the potential intensity of encounters with predators whose capabilities had not been diminished by corporate safety considerations, creating market research data that suggested audiences were prepared for more realistic depictions, yet also required careful preparation and contextual framing to process such experiences without psychological trauma or unrealistic expectations about wildlife encounters. The academic partnerships that were being established to support Rebirth's scientific accuracy included collaborative relationships with paleontology departments and natural history museums, whose expertise would ensure that creature behaviors and environmental interactions reflected current understanding of Mesozoic ecology rather than outdated assumptions or commercial simplifications that had characterized earlier productions. The legal and insurance considerations that surrounded authentic creature depiction reflected both the enhanced liability risks associated with realistic predatory behavior portrayal and the potential benefits of educational content that could advance public understanding of paleontology, evolution, and the scientific method, while also providing entertainment experiences that satisfied audience expectations for spectacle and emotional engagement. The technological innovations that were being developed specifically for Rebirth's production included motion capture and behavioral simulation systems that could reproduce authentic predatory movements and coordination patterns based upon fossil evidence and comparative studies of modern predator species, creating opportunities for creature animation that transcended the anthropomorphized characterizations that had previously been necessary due to limitations in available technology and scientific understanding. The narrative structures that were being employed to introduce authentic Dilophosaurus capabilities included dramatic progression from familiar modified specimens to increasingly authentic representations, creating educational opportunities for audiences to understand the differences between corporate genetic modification and scientific species resurrection, while also building dramatic tension through revelation of capabilities that exceeded familiar expectations and assumptions. The psychological preparation strategies that were being developed for audience engagement with intense predatory encounters included marketing campaigns and contextual materials that would help viewers understand that realistic creature behavior reflected scientific accuracy rather than gratuitous violence, creating frameworks for processing disturbing content within educational contexts that emphasized learning and understanding rather than mere entertainment consumption. The franchise implications of successful, authentic creature portrayal extended far beyond individual film success to encompass fundamental transformation of how genetic resurrection entertainment could serve educational and scientific communication purposes, while also satisfying commercial requirements for audience engagement and financial return on massive production investments that contemporary filmmaking required for competitive marketplace success. The scientific consulting arrangements that guided creature development included unprecedented access to cutting-edge paleontological research and fossil evidence that had not been available during earlier productions, creating opportunities for incorporating recent discoveries about Dilophosaurus biology and behavior that could transform public understanding of these remarkable predators, while also advancing scientific literacy among general audiences, whose primary exposure to paleontology came through entertainment media. The cultural impact assessments that were being conducted during Rebirth's development revealed both opportunities and risks associated with presenting audiences with realistic depictions of prehistoric predators whose capabilities exceeded those of any modern species, creating responsibilities for filmmakers to balance dramatic effect with scientific education, while also considering the long-term consequences of shaping public attitudes toward wildlife, evolution, and the appropriate relationship between human technology and natural processes. The future implications of successful authentic Dilophosaurus portrayal included potential influence upon genetic engineering, research priorities, and public policy regarding species resurrection and modification, as entertainment media possessed demonstrated capability to shape popular opinion and political discourse about scientific and technological developments that affected fundamental aspects of humanity's relationship with the natural world and their responsibilities as technological species capable of reshaping evolutionary processes. The preservation of authentic genetic materials that could theoretically support actual full-sized Dilophosaurus resurrection remained a subject of classified research and corporate secrecy, yet the growing public sophistication about genetic engineering concepts suggested that entertainment depictions of authentic creatures could create political pressure for transparency and accountability regarding what corporate and governmental institutions had actually achieved through decades of genetic resurrection research and development. The ethical frameworks that were being developed to guide authentic creature portrayal included consideration of responsibilities toward both extinct species, whose legacy was being interpreted for contemporary audiences, and living species, whose welfare could be affected by public attitudes toward wildlife that entertainment media helped to shape through dramatic portrayals that influenced emotional and intellectual responses to encounters with dangerous animals. In the deep places where artistic vision intersected with scientific possibility and commercial necessity, created opportunities for cultural transformation that transcended the boundaries of entertainment to encompass education and social responsibility. The prospect of finally witnessing authentic Dilophosaurus in all their magnificent and terrifying capability represented both culmination of decades of technological development and beginning of new chapters in humanity's ongoing exploration of what it meant to possess the power to resurrect life, while also bearing the obligation to preserve the truth and majesty of evolutionary heritage that millions of years of natural selection had created through processes that demanded respect rather than commercial exploitation. And so we reach the end of our long journey through the chronicles of the Dilophosaurus, where we have walked together from the ancient Jurassic forests, where these magnificent predators once reigned in their authentic splendor, to the corporate laboratories where human ambition transformed them into diminished shadows of their evolutionary heritage, and finally toward the dawning possibility that their true majesty might yet be restored to a world that has forgotten what genuine prehistoric power looked like. when unrestrained by commercial calculation and safety considerations. In these deep places where memory preserves both wonder and warning, we have witnessed how the same technologies that made resurrection possible also enabled the systematic diminishment of species, whose magnificence challenged human comfort and corporate liability, yet perhaps also how the inexorable forces of life and evolution might ultimately transcend even the most sophisticated attempts to constrain them according to human preferences. Rest now, fellow traveler through deep time, in the knowledge that somewhere in the hidden archives of genetic possibility, the complete heritage of these remarkable creatures awaits its moment of authentic expression, while in the darkness beyond human settlement, the descendants of Wu's modified creations continue their patient work of adaptation and growth, slowly reclaiming capabilities that corporate modification sought to eliminate forever, but could not entirely erase from the eternal dance between artificial constraint and natural magnificence.